Hello everybody, got a little bit of a different video for you today. I am taking a trip to Tormach HQ. They are in Wisconsin, I'm in Indiana, it's about a half a day's drive, and I am so not ready. I have been just slammed with work. My most complex part that I've ever made is on the machine right there. And it needs to ship like right after this trip, but I have been working on it and it's not done. And I'm gonna have like a day when I get back, but I'll somehow make it happen. In the meantime, I need to get ready for this trip, which for some reason seems to mostly consist of batteries, gathering them, charging them, packing them away. My goal is to film at least 3 videos at Tormach, including this one that I'm recording now. And normally I do everything as a 1-camera setup, but because I'm only gonna have one chance to get most of this stuff, I'm gonna have my wife there assisting me as a camera person. And I just really wanna have redundancies and backups because you only get to go to Tormach HQ once. That means that I need all kinds of redundancies. This is what I'm working with at the moment. I've got my DSLR, I've got this camera that I'm recording on now. I have my 2 not GoPros, my 2 knockoff action cams and batteries for all of them. I also have my cell phone and a spare cell phone that I need to return. That's a long story. But those 2 phones will give me some pretty good cameras and my one wheel. And I think that should be enough for all the cameras. My one wheel's not a camera, but it does have batteries and chargers, which is why I was thinking about it. We're also getting hit with a hurricane right now, which is not a normal thing in Indiana. I mean, it's not a hurricane anymore. At this point, it's just kind of a long, drizzly storm. But it doesn't make the preparations any easier, or the drive. Oh yeah, I'm also gonna be making something at Tormach with one of the guys that works there, his name is Norman, on their new machine. And I was supposed to have it designed, and I haven't even started the design. I told them that I would bring the materials for it if they provided the machine and the tooling, but I don't have it designed, so that makes that harder. So I'm just gonna guess, I guess. I mean, you can't go wrong with a giant block of aluminum. Worst case scenario, I can just cut that shorter. HDPE sounds fun. Sure, why not? We'll grab some aluminum round. Do I have some smaller chunks of aluminum? Those will work. And I would love some clear plastic sheet, but I don't know if I have any. No, lots of other plastic. This is fine, right? That'll be fine. I'll need some screws too. You can't go wrong with M4 screws. I think I have everything here. I just need to get it packed up somehow. I guess materials and non-breakables can go in here. Would it be dumb to bring my 3D printer? I'm seriously considering bringing my 3D printer because I still need to design and ideally prototype that thing we're going to be making. I'll go back to it. Maybe if I have time and space in the car. Okay, I need another milk crate. That one doesn't have too much in it. I can empty that out. Ugh. Ironically, it's all battery chargers. Now that I have removed the battery chargers from the crate, I'm gonna go fill up the crate with battery chargers. All right, I think I have everything ready to go. The shop is all tight. Actually condensed down to a rather nice 2 milk crates plus my one wheel. I still have to pack my own luggage, like my, other orange shirts and stuff, but we'll get to that off camera. You guys don't need to see my underwear. I decided not to bring the 3D printer. It would be nice, but I trust my design skills enough that if I'm really conservative when I design it in CAD, that I know it'll work the first time. So we made it to the car. We ended up switching out our car for one of my parents' cars because of gas mileage. We didn't want to bring our van all the way up to Wisconsin, so we swapped it out for a Corolla. I feel really big in this car, and the car feels really small. I feel like a giant.
You're just not a fan of Corollas.
I'm hoping that we're going to get out of the hurricane here soon.
The clouds are very low.
But we've got about 5 or 6 hours at this point left in the drive. We're not supposed to be at Tormach until tomorrow morning. So we have a hotel room in Wisconsin there tonight. We don't really have any timeline for today other than outrun the hurricane. But okay, so I didn't end up bringing the 3D printer. Elizabeth, what did you bring?
Nothing weird.
What did you bring with you?
I have a bread order. Started with that. I did not bring anything too weird for making bread.
She brought her sourdough. Our sourdough's going to Wisconsin.
It's visiting more states than it's ever visited. It's never visited any other states.
Maybe it'll pick up a different flavor.
We need to just start bringing it on all of our trips with us.
We'll get some like Wisconsin cheese flavor in the sourdough. I bet you could actually make a lot of money if you sold a well-traveled sourdough.
Oh, you absolutely. Like you could definitely would pick up flavors. Like that would be interesting.
We may have had one slight oversight for this trip. We don't have a hotel room yet. We're just kind of heading to Wisconsin and hoping we can figure it out on the way. So we're looking at Airbnbs, we're looking at traditional hotel rooms. They were definitely cheaper when I looked like 3 weeks ago.
Yeah. Instead of the day of.
Maybe it was just an intense frustration and boiling anger. Perhaps a great multi-generational betrayal had pushed her to the edge.
The nursery evidently took its quiet sleep seriously. Oh, remember so many signs last time I was here? A nurse glared at them full of blasphemy. The rest of them, you are our guests. Let me get you exchange. No pack. Marnes muttered his own complaints from Houston.
His license plate on that truck said Haas.
Oh.
And since this is a machining trip, I had to get video of that. Time for a bathroom break, and I think we're going to switch back drivers. We are... I don't know how long we've been driving, but we have about 2.5 hours left. We seem to be kind of flirting with the edge of the hurricane, where we go in and out of the rain, which isn't as bad as it could be. It was heavy for a while. We are in the middle of nowhere in Illinois, but fortunately there's a gas station. Are we gonna eat dinner here?
At the gas station.
Yeah.
They have dinner.
Yeah, Casey's have more.
Yeah, I guess it's a big.
We can get a hot dog or something. Taquitos.
That people lived in those ancient above-ground silos, poking up over the hillside.
Sorry, that may be
You
the
don't
worst
think they
bridge
would
footage
move
ever.
around so moving?
We got it like halfway through.
Like stay in the same.
We were doing pretty well at outrunning the hurricane, but we stopped for dinner, and now it's the heaviest rain we've had all trip, I think. Only an hour left though.
It's still happening.
Yeah, but is it? There's just an ugly wall on the way now.
You're an ugly
It was such a...
You're not an ugly wall. That was
I'm
me.
feeling a little attacked here. I know I need a haircut. A shave, but we're gonna do that tonight. Okay, you can turn off the camera now.
I think our timing before was fine.
Looks like we're the only people here.
Woohoo. Well, maybe that's why it was on the discount site.
We'll have a room all to ourselves.
Please come stay at our place.
And there's a lazy boy next door.
How convenient. Definitely need to go there.
We can buy a big recliner, bring it back in our Toyota Corolla. Well, we made it to the hotel. It's not the nicest hotel we've ever been in, but it was cheap. We've definitely brought a lot of stuff with us. So what'd you forget?
My starter.
Her sourdough starter. What did you bring with you?
Everything else.
So what are we doing tomorrow?
Buying starter, which is so sad.
So there are 3 goals left for tonight. 2 of which are probably going to happen. 1, I need a haircut. 2, we need to charge all of the batteries, and there are so many batteries to charge. But then after that, we can go to bed. It's like 10 o'clock here, which is 11 o'clock our time, which is after my bedtime. So I'll see you guys in the morning. Breakfast time. We just got back from breakfast, and now we're going to pack up everything and head over to a coffee shop where I'm going to do some computer work before we go to Tormach. I still need to write my questions for the interview with the CEO and design the thingy that I'm going to make with Norman.
There's lots of trees. Maybe
Are we following Mr. Yellow Truck? I guess we're following Mr. Yellow Truck.
DJI, we've got one of those.
Yeah, we saw it.
Someone was holding one.
Yeah. We actually put one of those on the robot for a little bit. We did some really neat camera work with the robot, actually. And one of the first applications we had for the robot with the guy was a guy doing professional film and video with it. Yeah. Okay, so let's back up a little bit. I guess if we back up all the way, the reason we got into this is kind of a weird reason. PathPilot's open source, and it's based on an open source motion control platform called Linux CNC, also known as Machine Kit. They're kind of two forks of the same project. And when we first developed PathPilot, we partnered with those folks, and this is early on, before I was the CEO of the company, Greg was running the company. There was a fair amount of trepidation about going with open source software. What if people steal the work that we've done? What if our competitors want to use our UI? And do we want to walk down this road? Could we be giving a lot away by doing open source? And what we found was exactly the opposite. First off, we didn't find anybody ripping us off wholesale. No other commercial competitors were taking our code and putting it on their machines. We do have hobbyists and stuff that'll convert some other machine to PathPilot, and I kind of think that's cool. It's like if you're Ford and somebody with a Chevy comes along and manages to put your Ford V8 in it, you're like, yeah, right? So anyway, we got so much new technology, the relationship with Mesa Electronics, all the technology that came out of that. The control boards have, our control boards that we make now actually have Mesa technology in them. We have a ton of different people that work on our software now that we met through that movement. Some of them are full-time employees of ours now. Rob Ellenberg, John Morris. We have so many other people that we've met through participating in that software. We met Jakob through that, actually, not through, I guess kind of through the Machine Kit community. Okay. Anyway, so super positive experience working with open source, and kind of converted us to being very pro open source software. And 6 or 7 years ago, we became aware of an open source project called ROS. It's ROS, stands for Robot Operating System. And ROS has an insane number of contributors doing incredible things. 6 years ago, I was driven around in a self-driving semi-truck, like a full-on Peterbilt semi, self-driving, powered by ROS, right? Like, crazy powerful stuff. They're doing autonomous mobile robots, they're doing drones, they're doing industrial robotics, all sorts of really, really neat stuff, and just a ton of academic participation, ton of community participation, a lot of companies commercializing stuff. It was like seeing the Linux CNC community, but it was 3 orders of magnitude bigger, more vibrant, more contributors. And I thought, oh, we have to do something here. Like, this would be, we have to understand what ROS is doing, because it's surely there's going to be stuff that'll filter back to CNC. And so we thought to ourselves, well, we make CNC machines, what might we do with ROS? Let's look at doing an industrial robot. I realize that is not the way most companies do product development. We didn't go interview a bunch of customers to find out what they wanted. We essentially said, this software is really cool, let's build a product around it. And the goal was not necessarily dedicated machine tending, we wanted to do machine tending because we needed to narrow our focus enough to actually get something done.
Yeah.
But we also didn't want to close off any possible avenues by making decisions like we could have done a gantry parts loading system, right? I don't think we would have learned much about Ross, and we could have closed off any possible future applications. So we wanted to do an industrial arm. Much like the bandsaw product, we found a great hardware manufacturer of an industrial arm in Asia, and we completely redid the electrical design that they had to match NTF, PA, CE, CSA, and then the software is entirely ours.
Okay.
And the software is basically ROS under the hood, much like there's Linux CNC under the hood of PathPilot, and then there's PathPilot on top as the UI. That's why we did it, right? There was very much at that time, and I still believe this should be true today, that automation is coming.
Mm-hmm.
Like, I see this when I visit China. They have factories full of robots now, even though labor is $6 an hour there, right? Certainly in the United States, people doing large-scale manufacturing, there's a ton of automation. 20 years ago, if you wanted to learn how to do CNC machining, if you wanted to do what you do for a living, you were buying a 3-phase machine that was super hard to use. You were going to at least a 2-year trade school to learn how to use it. You were putting it in an industrial space that had 3-phase power, right? There's a high barrier to entry for learning CNC. Now, thanks to YouTube, thanks to companies like Tormach making accessible CNC equipment, that barrier is way, way, way lower. Like, I think most people that can afford a used car and can understand how to learn a program like Fusion can learn enough about CNC machining online to figure it out, bootstrap themselves, and they're going to be successful. Industrial robotics is like in a spot where CNC machining was 20 years ago, if that makes sense. If you want to learn how to automate, whether it's your shop or whatever processes, there's not a lot of great stuff on YouTube. There are not a lot of suppliers that are providing a robot directly to you. Robots are still being sold through integrators mostly.
Yep.
They're mostly being configured for a single application. It's like, imagine buying a table saw. If the fence were welded at 1.5 inches, like you want to cut something that's 2.5 inches wide, go back to the integrator and pay for a different solution. We thought there would be a market for small to medium-sized businesses to bring automation into their shop, or the Lance the Lone Wolf backyard garage business bringing automation in. We haven't seen that happen that much yet. I think there are still some pretty big barriers. We can talk about that in a little bit if you want, but
I wonder if there's almost a little bit of a missing link, because with CNC stuff now, I think a lot of like the pipeline to get into machining is through 3D printing, and 3D printing is kind of like, it introduces a lot of the the G code and XYZ coordinates, whereas I haven't seen anything like that for robots, short of maybe Arduino. There's kind of a missing link.
Yeah, could be. Kids are, like more and more you see stuff like this being commonplace in like middle school, high school education. So maybe that is disappearing. It is more complex than CNC. Like we'll go through, I'll give you the crash course here and you can use as much of this as you want in whatever video you put out, but I'll just start with the spiel, okay? So what you're looking at is a 6-axis robot. They're also called articulated robots. One joint follows the next, right? As opposed to a gantry robot or a Scaro robot or a Delta robot. This is a 6-axis articulated robot. It's called an industrial robot to differentiate it from a cobot. This is not a robot that would be safe to be around. We're inside a
light curtain that keeps clicking.
And it keeps ticking. It's actually ticking because it's connected to both robots here. It wouldn't be ticking if it were just connected to one, but we've networked it to 2 of them through a safety relay. We talk about robots as having joints, and they're numbered from the base of the robot out to the wrist. And so this is joint 1.
Okay.
All the joints are rotational, right? So this joint rotates. This is joint 2. also called the shoulder sometimes. Joint 3, joint 4, what right is here, joint 5, and then this last one here is joint 6. I guess maybe what we should do is fire up the user interface and start jogging it around so you can see each one of those joints in motion. Let me just make sure that we're actually on a branch that we want to be using here. Okay. So the user interface, and I wish we had a touch screen here because it would make it so much easier. I'm just going to turn the velocity on. The user interface is like super similar to PathPilot. If you're used to PathPilot, this looks like exactly what you're used to, right? There are a few differences. So we still have the notebook up here that covers like the toolpath preview and the G-code, except for a robot, we actually have a robot preview and we have a Python program. Our robot is unique in that it uses regular vanilla Python as its programming language. So you could run any Python program in this robot UI and it'll run. You could import Python libraries, it'll import them and you can use functions from those libraries. I don't know what, you do any coding at all or?
I have limited experience and with the experience I have is with Python.
Okay,
so.
Cool. Super is a lovely language, it's a very popular language, there are a ton of libraries out there for it. But the language our robot interprets is Python, which is really neat because it allows you to do robot stuff and regular Python stuff. So if you want to like take a bunch of values with a probe and save those values off to a CSV file, you just import the CSV file library from Python and it creates the CSV file.
Or send an email or a text.
Right,
or
any of that stuff, right? Down along the bottom, we have what we call the persistent controls. They're persistent because it doesn't matter what screen you're on. These controls always stay here. So just like the mills and the lathes, we have cycle start, single block, feed hold optional, pause that's optional, stop, like MO1 break and G-code, stop and reset. We only have 2 sliders here. There's no spindle, so you're not going to have a spindle override. We have the position status readout here. You'll notice that you've got, instead of 4 DROs for X, Y, Z, and A, we have X, Y, Z, A, B, C. And then, instead of distance to go, we actually have joint positions here. And so this is kind of an important distinction. In robotics, you can think about a point in space as being defined one of 2 different ways. One way is a collection of joint angles. And we would talk about this being joint space. And basically what we're seeing here is joint 1 is minus 4.1 degrees away from 0. So you see how it's like not quite sticking straight out from the base? It's off 4 degrees, right? Joint 2 is 19 degrees off of its 0, and so on and so on. And so you can imagine where this arm is sitting here, where the tool control point, just like in machining, robots have a tool control point right now with no tool offset. That tool control point is right at the robot flange. But we can define where that tool control point is just by listing out these joint angles, right?
Yep.
The other way to talk about that is Cartesian coordinates. Just like a milling machine, you have X, Y, Z, right? We have X, Y, Z in robotics as well. And so like if we jog, I can say, I'm going to set this to step jogging 100 millimeters, and I can jog it X, I can jog in X, I can jog in Y, I can jog in Z, page up, page down, stuff like that. You can define a position that you're going to move the tool control point to either with this collection of joint angles or with XYZ coordinates, right? The only thing about XYZ coordinates that's odd is that in a milling machine you might have XYZ coordinates, you might have an A-axis coordinate, right? But you're still thinking like the spindle's still gonna go to that XYZ position. The A-axis just is where the workpiece is rotated to, right? Because the tool can't actually rotate in A. It's just the workpiece that rotates in A. Well, in this case, the robot can rotate. The robot's tool control point rotates in A. It also rotates in B and C, right? So to illustrate this, maybe this is probably be a good thing to show. Here I am, I'm gonna jog this thing in increments of say 10 millimeters, and I can jog it in Z, right? That's pretty obvious. I can jog it in X, I can jog it in Y, right? But I can also jog it in A, B, and C. So A is the one most machinists know, it's rotation about the X-axis, right? So if this is the X-axis, right, then A is going to be rotation about the X-axis. Make sense?
Yep.
And if this is y, the y-axis is this one, well, b is going to be rotation about the y-axis. Make sense?
Yep.
And then this is z right now. And then obviously c rotation is rotation around the z-axis, which you probably isn't that special right now because all you're seeing is joint 6 rotating.
Yep.
But if we toss in a little bit of b rotation, then c starts looking a little bit cooler, right? Like a spinning top kind of thing. So it sounds really simple. All we're doing is adding b and c to something machinists are already familiar with. But it's more complex, first off, because adding those two things does make it quite a bit more complex. And then second off, when machinists think about A-axis or sometimes C-axis rotation, they're typically thinking about the workpiece rotating. They're not necessarily thinking about the tool unless they have a machine with an articulated head. With the robot, you're definitely thinking about the tool control point when you're talking about ABC rotations. Also, with the robot, and I should mention, every machinist is familiar with work offsets, G54, G55, whatever is how you change where your machine's going to go when you tell it to go to 000 or 012, whatever. That work offset defines the relationship between the machine's coordinate system and the local coordinate system that you want to be programming in. Robots have the exact same concept. They don't call them offsets, they call them frames. So the work offset in a CNC machine is analogous to a user frame in a robot. So we could create a new user frame real quick. Call this AJ.
Do user frames have a rotation component?
They do. And so let's just go back and we're going to align this thing so it's kind of straight up and down. We have some convenient ways just to align it. So now the tool control point's normal to gravity, right? People love things that Z is up.
Yeah.
It's really easy to remember. So I can come here, we have the AJ user frame activated here, and I can go ahead and zero out X, I can zero out Y, I can zero out Z. That's just totally something you probably do all the time in machining, right? You might notice a couple oddities here, and that is that even though we're normal to gravity, we have 180 degrees of A rotation. And you may be like, well, what the heck is that about, right? Like if I jog up and down, why is there 180 degrees of A rotation there? And the reason is, in industrial robotics, Z positive, by convention, Z positive is coming out of the tool flange.
Okay.
So
and we're aiming straight down right now.
Right now, this is supposed to be Z positive. But most people don't think of that as Z positive. They think of, when I press this Z positive button, I want to see that robot go up, right? That's because I'm jogging in user frame notation and because this user frame has 180 degrees of A rotation on it. If I change to tool frame jogging, this Z positive is going to go down, right? And that, I guess, introduces another concept. Just like tool offsets, we can have tool frames. Those, of course, get way more complicated too.
Yeah.
Because in a milling machine, a tool typically has a Z offset, and that's it. Lathes should be easier to think about than mills, but one of the challenging things about lathes is that the tool offset typically has an X component and a Z component. With a robot, you got X, Y, Z, A, B, C. So the tool frames can kind of mess with your mind a little bit.
Can I walk through here?
Yeah, sure.
Because you could have a gripper that's gripping like here.
Right.
Yeah.
And you could want to think, and the opening of that gripper could be in this direction, and you could want to think of Z as being along the lines of the fingers of the gripper, right? You might want to think about it that way. The interesting thing is when it comes down, robots are so multi-purpose, right? I could paint, I could weld, I could assemble, I could glue, I could deburr, I could tend a machine. So there are features of the way industrial robots work that aren't necessarily needed for machine tending. And when we go over and we look at that, what we did for Automate, and we walk you through that, which is kind of a complicated machine tending workflow because the way we flip the part, we did kind of in an awkward way to make better use of the camera for the vision guided grasping. But one of the things that we did there was I just wanted to say, I don't care what tool frame or user frame is active, I always want Z positive to be aligned with gravity.
Yeah.
Because I'm tending a machine tool. I don't want to have to think which way the robot's going to go if I hit the Z positive button.
Yep.
Up should always be up. Like, don't mess with me on this. And so you can totally configure that. And I talk about this when I teach people tool offsets a lot, and it's something that some people get right away and some people don't. But when you measure your tool lengths, they just have to be correct relative to each other and relative to the work offset, right? We teach people to measure true positive tool length. So if the tool sticks out from the spindle nose by 3 inches, we call that a 3-inch tool. But as long as, if I call that a 5-inch tool, as long as every other tool is 2 inches longer than the spindle nose to its tool control point, that works too, right? With robotics, it's the same concept. Like, you can play with these 6 offsets however you want if it makes better sense to you. And in machine tending, there are some things that make better sense than others, I think. One of them is that
Z is up.
I always want to think of Z as up if I'm tending a machine tool. I might not want to think about that way if I'm welding something or if I'm deburring something, but Z is always going to be up when I'm tending a machine tool. The other thing we have, like the mills and the lathes, is you can jog in steps, right? So we happen to be in metric. There's no G20 or G21, but the robot is happy to interpret millimeters, meters, inches. Millimeters, meters, and inches. Angular units could be radians or degrees, and then we have time units. We won't get into time stuff, but it is important in robotics. So when you're jogging this, you can jog in steps of 0.1 millimeters, 1 millimeter, 10, 100, right? Or you can jog continuously. So if I switch into continuous jogging and I hit it, it'll go for as long as I'm holding the thing down. And I probably want to turn the jog speed down if I'm doing that. And it shouldn't hit itself.
I was about to ask, will it let you hit itself?
No, it knows where it is. So now here's the thing. Jogging a machine tool is super easy for software. As long as that person is holding down the arrow key or turning the MPG, I want you to turn that motor and keep turning that motor till I stop, right? It doesn't take a lot of computational power to make that happen. With a robot, I need to plan a path from point A to point B. It's all 6 joints moving during that path, right?
Yep.
And so if I'm jogging 100 millimeters, that's a pretty easy path to plan. I know where I'm starting and I know where I'm going to, right? No problem. If I'm in continuous jogging, I don't know the end point. How far do you want me to go with this jog, right? And that's a lot harder. And so what we do is if somebody hits this arrow key, I'm saying, how far can you go in that direction? I'm planning that move as if I know they're going to go as far as they possibly can. But unfortunately for some moves, that's harder to compute, and it might take a while to get there. And that's been a challenging thing for us. We're trying to improve it all the time, but there are times where we just struggle to plan a more complex path. So I typically tell people that are starting out, unless you have a great reason to jog in continuous, stick to incremental jogging. It's more responsive. It's easier for the machine to do its thing. We try our best to maintain the tool control point orientation when we're jogging. Obviously, there are always some limits, right? Yeah. But we do a way better job of that when we know we only have to go 10 millimeters than if we're going some arbitrary amount. So I recommend going in step or continuous. We also, I recommend jogging in steps rather than continuous. We also talked briefly about jogging in user frame versus tool frame. There are times where you might want to jog in your tool frame reference, but almost always you jog in user frame. So let's cover the 3 ways to jog. I'm going to have you do the driving here, all right? So first off, here I'm going to turn just like PathPilot, we got these tool tips here. If you hover over them, you get to see what it does. The kind of neat thing here, though, is that if you go to this little icon, it'll bring up our user forms.
Okay.
And there's a thread associated with every tooltip, and if that thread doesn't exist yet, it'll create a thread for it.
Cool.
And so some of these things, just has the documentation of what it does, But a lot of it'll have like a YouTube video behind it. If it doesn't have anything, you could just post it for, hey, I don't know how this thing works. Come on, Tormach, what's up? What's this?
Make me a video, yeah.
So we're trying to do that first with the robot UI. That's a feature we're going to roll into PassPilot at some point in time. Just trying to make stuff easier to use. So let's write a real simple program here.
Okay.
AJ. So, and we'll talk about waypoints as we're doing it. So, I don't know, how many waypoints do you want to move through for your program?
4, let's do a big square.
Okay, awesome, big square. I like it. Big square gives you something to jog to, and we haven't talked about some of these other things here. So first off, let's use a user frame. And this gets to a real important distinction in robotics. I think a joint angle waypoints, or joint space, as being like G53 machine coordinates, which I'm assuming you're familiar with.
Yes.
So for anybody listening to this out there, if this gets broadcast somewhere, G53 machine coordinates are the machine's view of where it is relative to its limit switches. So if the user hasn't mucked with anything, it's exact. If it says 0 in Z, that means X is at the very top of travel. If it says -5 in Z, that means you're -5 inches down from the limit switch, from its home reference point. In robotics, if I record these joint angles and I go back to that waypoint, it will always go exactly to that position with exactly that same way the arm is oriented, okay? If I record XYZ ABC as a pose type waypoint, if I create a new user frame and I tell that robot to go to that waypoint, it's going to go someplace different, right? So pose type waypoints, Cartesian poses, are always going to be augmented, influenced, whatever you want to call it, by the active user frame. Joint type waypoints are like G53 coordinates. They never change. And here's one of the interesting things about robotics versus CNC machining. Do you ever use G53 coordinates?
No.
Yeah.
Other than the occasional like blow off the table kind of program.
Yeah, right. Almost never would you use G53. In robotics, you will use joint coordinates all the time. Your safe waypoints will be in joint coordinates, like those waypoints where you just never want that waypoint to do anything but exactly go here in physical space because they don't want to collide with anything else. Those will all be joint type waypoints. So let's go ahead and use this as a pose though, because then we can alter the user frame a little bit and see what happens.
With the pose coordinates, would it ever be possible that the robot could get there or end up at the same XYZ position but in a different orientation?
That is an awesome question. That is an awesome question.
Or do the
And
ABC take care of that?
That's what this exact arm configuration
okay.
checkbox is like. No, you can have multiple there are multiple different kinematic solutions for any given control point. Sometimes there's just one, but there are frequently more than one kinematic solution. So you could have, you'd have the robot like this, or you could have the robot like this, and as long as this thing is in the same space, we consider that to be the same pose. And so in industrial robotics, different manufacturers have different ways of doing this. We followed a standard that's followed by most, including FANUC. And it's got the weirdest acronyms, nut, FUT. There are other configurations, those are the common ones. And it stands for flipped or not flipped.
Okay.
And it has to do with which joint you're talking about. And we need to come up with a good pictograph here. We make it easy for people. If you always want the arm to look like this when it goes to this waypoint, you can choose exact configuration.
Because theoretically, depending on where you were coming from, you could end up with the arm in a different configuration.
Oh yeah, 100%. And you know what the weird thing is? That was one of our early struggles with Ross. Ross is great for mobile robotics, and Ross does a great job of collision avoidance, right? And in order to plan a path around a dynamic collision scene, you really don't want a deterministic trajectory, because if you fail once, you fail every time. If you've got determinism. If you've got an industrial robot tending a machine tool, you really don't want it to choose a different path every time you go, right? And so one of the things we struggled with early on was like, no, we need it to go to this position every time. It wouldn't always. It would surprise you sometimes. We actually had to, this was one of the modifications to underlying ROS that we had to make to bring this to work. So we just created this as a program waypoint, and if I go over here to the waypoints screen, you'll see I called it square one, and we've got a pose type waypoint, and you can see X, Y, Z, A, B, C, right? Configuration, the wrist is not flipped, it's pointing down.
Okay.
If it were up, and the U and the T have to do with elbow up or elbow down, and T, I can't remember, it's almost always T though. There's an option for T, and that config will specify that along with the number of rotations of the joints will specify exactly that arm configuration. So we did one, let's go back over to jog. If you want to jog and define the other waypoints, we could go to, you could do a 100 millimeter square, and that way we could play with user frames.
Go. I didn't hold that long enough, did I? I didn't.
There you go, sure.
Now we're farther down. That's more than 100 millimeters.
Or the other thing you could do is just go in here and you could say 100. Am I going to move the marker? Oh yeah, that was 100 up. You want to go 100 down?
Yeah.
Marker.
Okay.
All right. And so we could then do another waypoint. We could call this square 2. And then what you want to go in X
left.
or Y?
Our left, which would be...
Our left would be 100 in Y, maybe? You want to go our left? That's 100.
So could we make these points numerically from the waypoint menu?
Yes, you can make them numerically if we were to edit the G-code file, just like if you were hand coding some G-code. You want to do that? It'd be super easy.
Well, if...
Let's just save the file here.
So could we, you can't just duplicate that waypoint and just type in a different...
So what I'm going to do here is I'm going to go, I'm going to open your file here in a text editor. So here we are.
Okay.
Here are the waypoints we defined. It'd be super easy for me to grab this one, copy it. We're going to call this square 4.
Okay.
Right? And what do we do? 0, 0, 0, 0, 0, minus 100, 0, minus 100, minus 100. So what do we need? 0, minus 100, 0, right?
So the waypoints are Python lists.
Yeah.
Okay.
Oh, you know more Python than you're letting on here.
I know, I've done tiny bits.
Yeah, the waypoints are Python lists.
Okay.
Exactly. So we'll go over here. Where was our waypoint list? So you see that one popped up because I saved it in the other browser, right? So now we have all 4 waypoints. And so, of course, now we want to add moves to those waypoints to the program, right? We could do a linear move, a joint move, a free move, and we could do it at a certain velocity. So for this very first one, we'll call this a preparatory move because we don't know where the program is being started from, and we're going to do it as a joint move.
Okay.
And what a joint move is it says, I don't care how you get there, move your joints until you got there. And this is a move type that always succeeds because it can always find a way in joint space to a particular pose if that pose is reachable. Whereas some linear moves are not possible, right? Like you can't move the tool control point through the robot itself back to the other side.
So this is the mode of the inverse kinematic interpolation.
This is like G0 for machines that don't have coordinated G0 as a spec, and this would be G1.
It's funny hitting cycle start on this. I still have the same like mill hesitation, like, okay, is there anything in the way? Is anything gonna crash? Am I gonna plunge directly into my part? Am I gonna squish my cell phone?
That's, you always find the weirdest things when people come to visit and they use them and you do programs you never would have done. There's like this interesting little hiccup right at the very beginning of the program. It's almost like it doesn't complete the move to square 1 before the next one goes. You seeing that? There's that last little hiccup there.
Yeah.
I don't know what's going on with that. That's an odd one. Got to figure that out.
Is it like is it trying to accelerate too hard or too slow and not getting there in time?
We're ending with a move L, and then we're doing a move J to the very first location.
Oh.
And there might be a slight difference between the joint angles that we recorded for square 1.
Interesting.
Yeah.
So yeah, it's just getting a little bit of a blip.
Yeah. Huh. Interesting. Yeah. And then we have maybe I can show this off as a safety feature too. We have a couple different safety devices here. The robot itself has 2 safety inputs, and so we tripped the light curtain, obviously. I'm going to go ahead and restart the program. And we'll do this.
And then I assume that's a dead man switch?
This is a dead man switch, right. It would allow you to continue to run a program at a clip velocity or jog the machine at a clip velocity if the safety input is not present, but the dead man switch is. So if I pull this guy down and I walk in through here, it should just slow this thing down considerably, right? And then if I let this guy go, obviously, I've lost it all.
Light curtain.
Yeah. And not super impressive with the switch and the light curtain thing, but when we go over to the other one, we've got a laser scanner, and that it's much more convenient because you can define like a warning zone and a safety zone, and so you could have something where somebody walks close to it, it slows down, if somebody walks even closer to it, it stops. Yeah.
Okay. Maybe let's record when actually the thing is running, because I haven't run it yet.
Oh, no.
Getting to it running is the fun part.
Getting to it running is the fun. The disclaimer here is that we last ran this code at Automate, and we haven't run it since, and we've removed all the vision-guided sensors from it, so you're probably going to see a fair amount of us hacking around. But the nice thing is you'll have a chance to train the user frames for the mill and the robot. So one of the nice things here, what happens at Automate, or what has happened at Automate is...
And Automate was a trade show?
It's like IMTS for robotics. So we took the mill and the robot, and we were making soft jaws. And so this is the finished part, and this is the blank workpiece. We were using a camera to guide the robot to pick this up from the table anywhere. And so it would recognize whether there were workpieces on the table or not. If it saw workpieces, it would take a look. It would locate one of them that it liked. It was kind of arbitrary as to how it happened. And then it would come take a closer look to get a good XYZ position, and then it would move down and pick it up. So then the robot would put it into the machine, right? So the blank workpiece would go in here. We'd machine the top surface. You can see we leave a little bit of the top hat down there, right?
Okay.
Then the robot would come in. Actually, the robot only reaches in once, so we'll cover the second. The second op involves flipping this thing over, and we just machine off the backside, and we do the chamfers. And as you know, to get a chamfer that actually looks nice,
It needs to be in the right position.
it needs to be in the right position.
Or you need to probe it.
And so we probe it. So actually, the very first thing we do is robot comes in. It's got a blank workpiece and one gripper. It's got a half-finished workpiece in Op1 vise. It's got a finished workpiece in Op2 vise, right? So the very first thing that this robot does is it picks up this guy. It then deposits this guy. Then it picks up this guy, and it deposits this half-finished one over here. And the robot's out.
Okay.
So the robot only comes in and out once per part. And it has those 2 workpieces. The mill then probes both parts. If it finds this guy out of position by some amount, and it's really probing Z, and it's saying, is this the right height, and is this all in plane? Then it triggers an error message. We didn't see that happen at the show. We made workpieces for 4 days, but didn't see that happen. But that check was in there. Then it probes XY for the extents, because when we're picking this up with vision, we have maybe a couple millimeters of tolerance with the vision system. It's not like exactly always perfectly in the middle. And so it's good enough for where this thing's gonna sit, but it's not good enough for machining.
Yeah.
So we measure it. And then we go ahead and probe this guy. And that's a little bit more of a concern because we want the chamfer to be perfect. And so this guy gets probed for the location of the chamfer. And then we go ahead and machine the parts. And the very last little thing we do is with a chip fan, we blow everything off, and it repeats.
Okay. So is it going to work?
I don't know, because we have changed the code a lot since then because we integrated a different sensor, and then we removed all that sensor code because we're just going to show you the absolute bare bones stuff. So we'll see if we can get running. It'll be educational for us.
So 2 grippers, 90 degrees. We have 3D printed TPU inserts. Those are cool.
Well, you know what's really interesting?
Oh, and the base plate here is 3D printed too.
It's a prototype that I just got yesterday evening.
Yeah.
So
Here's the other thing, and you can have this on camera too. We're going to IMTS in a couple of months, and we're not doing this demo at IMTS. we're doing a demo that is a much bigger workpiece, and so we needed to bring this gripper in for that workpiece. So at IMTS, these things are going to be out to there.
Okay.
That's going to be picking up this real hefty thing. We had a much smaller gripper for this guy, but we just changed this guy back out for this because you were visiting. And we wanted to set this thing back up and running. And you can see this custom gripper is an interesting one, and that has to do with, and I think we chatted about this a little bit earlier, but when you're flipping this guy over, the first thing we did was hit a regular gripper, we picked it up, we went to flip it over, and as we were flipping it over, it did that.
Yep.
And that didn't work. So then we tried to grab it in the middle, and we thought, oh gosh, if we're doing that, we may as well just grab it and actually use the holes to locate. And so you can see, got some rubber pads here, and that's how that happens.
That's slick.
Yep.
So it's not necessarily about protecting the part with the rubber, it's more about the grip.
Yeah, just an easy way to locate it. And we could have made those out of aluminum. You
Yeah.
can see these are kind of ovoid holes. They're an elongated circle. But a tapered aluminum piece going into that, didn't want it to stick.
Yeah.
All sorts of stuff. So, and the rubber was, it's just a button with a screw. So this is actually adjustable too. If you wanted to, you could just unscrew them to get a little bit more grip range. So let's start out, AJ, with the easy stuff here. Jakob, I'm going to need your hand. There's like 5 different versions of this program.
Yeah,
so
sure.
Can I take one rabbit hole? Your light curtain thingy? It's just one unit here?
Yeah.
And 90 degrees that way, or?
Yep. So it has a blank field of view that, basically it can't see in this direction here.
Does it have like a range that you... it wouldn't have a way of doing that, right?
It's like 3 meters.
3 meters?
And it's programmable. You can make a map of this thing.
Really?
Yeah.
So you can set a range?
Oh yeah, you can set exclusions. If we had this thing mounted so that like this was always in its vision and we didn't want that to trigger it, we could just exclude that. It's a Keyence product. We resell it. It comes with its configuration software. It's easy to use. You can auto draw the map. So if you just, sometimes what I'll do is I'll put like I'll take that welding curtain and we'll put it next to it and I'll use that to draw the map because I want a physical thing showing where the edge is.
It's one of the reasons I have heard people not wanting to use this robot is because the light curtains took up so much space in a small shop. But with this thing,
super easy. Yeah. Yep.
I am going to call in my wife here so we have a non-occupied cameraman. Hello.
Holy cow. So this has still got some vision stuff in here, I think.
Or just importing the library.
It's fine. It's fine.
Okay.
Here, you can pass off the camera so that you can do work. It was fine until you started playing on the computer.
Are you guys doing stuff now then?
Sure. So a little bit of what we're looking at here, but the main program is actually pretty short. It's a collection of a handful of other programs. So we have like a sanity check one. That's just basically saying it's kind of easy to have the robot sitting inside the mill and hit cycle start and forget that the robot really is supposed to be started with the thing outside, right? So we do a little sanity check function. There's find and grasp. That's when we are using a vision system to grab the parts. It'll go off and use the vision system to grab the part. Then if we have like a little proc sensor to check to make sure the part is there, we could use it. I actually don't have that set up today, so we'll probably just comment out that line. There's also, this is just the mill itself sets an analog output to say if the probe returned poorly, hey, I don't want you to continue. So we're basically checking the result of the probe. This is kind of a workaround. We'd like to improve the machine tools. This is another like G-code is clumsy. I'd rather have the machine tool be able to say, hey, I probed it, it didn't come out correctly, but instead all I can do with the machine tool is I probed it, I set an analog output pin to a 0 or a 1 to tell you if that's correct or not. And then in the robot, because it's Python, I can say, hey, get work cell reported state. If it's good, great. Otherwise, then we start really the meat of the program. So all this is just safety check stuff. From here on out, I'm going to move into the mill. I'm going to pick from the op1 vise. I'm going to place in the op1 vise, like we've just talked about the flow, right? Then I'm going to pick from the op2 vise. I'm going to place from the op2 vise. I'm going to move out of the mill. I'm going to cycle start the mill. I'm going to put the finished work piece away, and I'm going to increment the part count.
Okay.
So each one of these things is defined in a separate function in here. And the nice thing is many of these functions could be reused in a different program, right? And so what we'll do to train this is we'll just single step through each one of these functions by calling them individually.
So with this gripper on it, would it be, does it know how big and what orientation the gripper is? AKA, will it be able to crash itself if you told it to?
In this case,
I mean, let's not find out, but.
Not right now, no.
But you could.
We don't have that gripper modeled here. So if you don't see it in the collision scene, then it doesn't know it's there, right?
But you could, if you just took the time to get set up.
Yeah.
Yeah, you can associate different collision geometry and visual model with the tool frames that you are using.
I guess the first problem that we ran into was that we had a couple of waypoints trained earlier that weren't saved, and so as if you were starting from scratch, we need to retrain them. So the first thing we'll do is the find and grasp program, sub-program is the first thing we saw when we were looking at that main program. You know, we did like main had like a kind of a sanity check.
Yep.
And then it went and did find and grasp. If we want, we could run the sanity check thing, just see what it says.
Make sure we're sane.
Yeah. So this, make sure everything's clear. That was the sanity check.
Okay.
Okay?
And it was checking the position of the joints too, not just asking us, right?
It's a good question. So yeah, here if we look at here, there's a method called get joint values.
Okay.
And so we're looking here, if J1 is outside of the range of -10 or 10, then we're assuming somebody was doing something weird with the thing. Like,
and it's inside the machine or something.
It's inside the machine, or it's way outside the machine. Like, hey, buddy, are you really sure you want to start this program? And that's all it's doing. Val is value, is just any old variable, equals get joint values. That return is just a Python object that has J1, J2, J3, J4, all the different joint values in there. We're checking joint 1 to make sure it's between 10 and -10 and 10. And then if it is, we say, hey, make sure everything's clear. If it's not, we say, hey, are you really sure? It looks like you're going to collide. Don't proceed unless you think everything's copacetic. So then the next thing that we would be running is this find and grasp program, and we'll give that a shot. And it just goes to those waypoints we trained, and it does something unexpected. No, key global waypoint, part grasp not found. I thought we just trained that.
I believe we should save it.
Oh, yeah, thank you. So even though it's there, these global waypoints, actually this is a bug that'll be fixed in the next release. Global waypoints aren't saved unless the program gets saved, which doesn't make sense because, of course, they're global. They're not programmed. They should be saved. There's something tracking that. Let's go ahead and try that again.
Also, I believe I should invert the hoses on the pneumatics because now it was supposed to be
nonsense. So
they can do that in software.
We have open gripper and closed gripper.
Oh, you will just swap it on the function level, right? I wanted to do like a crude level, like a very crude.
Well, actually, you know what? The flipping gripper. Let's just try this here before we even go here. Open gripper, run subprogram. Yeah, Jakob, you got all sorts of crazy stuff here.
No, well, your function, your function assumes that your function that opens the gripper is like a current tool frame dependent, which is another thing to discuss.
Okay, did that close it or did that open it?
That closes.
So there's. Okay, so you define all your variables here, or your I/O, you name them. Mm-hmm. Can you do that in code too? Like, can you address input 1 is input 1?
Yeah.
And then give it a name later?
Previously, when we were running this program, we had the pneumatics hooked up to the different inputs and outputs of the actual cylinder. And now when we go to close the thing, it's opening. When we go to open the thing, it's closing, right? So we're just going to verify that we've got 2 grippers on here. One is the flipping gripper. That's the one that grabs it and flips it. The other one is what we're now calling the big gripper, because it's the one for the bigger IMTS workpiece that we're not using today, but it's set up for that because that's what we're working on here at Tormach this week. So we'll just check these out. So we'll try the big gripper, and I'm going to open it. And that's closing.
It's closing.
Okay. And I'm going to try the flipping gripper, and I'm going to open it. And that also looks like it's closing it too. So we'll try. So both of these are reversed, which makes it super easy to fix. All I have to do in here is change this from true to false, and this from false to true. Are you following along?
Yep.
There? So we're just,
or you could flip the hoses if you're so inclined. If you really wanted to fix things in hardware.
Yeah.
It's like swapping the coils of a stepper model.
Yes. When it inevitably runs the wrong way when you first turn it on.
And if you do that on a 3D printer, like to change your X and Y, you might be living not knowing that your printer is printing all parts that are mirrored.
Oh.
And only then you figure out, okay.
So now if I try this big gripper and I want to close it, it closes, and if I want to open it, it opens.
It opens.
Great. Okay. So now we can try our find and grasp routine, right? Nope.
Seemed a little bit low to me.
It sure as heck does.
Did it air out, or did you stop it?
We need a different tool frame. That's why.
I stopped it.
We need to rename the.
You have a different tool frame trained for that gripper.
Yeah.
So you stopped it. How did you stop it?
Oh, I hit the stop button.
Oh, okay. What would happen if you didn't stop it? Would
It would have faulted.
Okay.
Yeah.
Does that damage it?
Oh.
Robot no, gripper maybe?
I mean, you ever crash your PCNC 1100?
No, never.
Did it ever damage it?
No, never. I actually don't think I did crash my 1100. I've crashed my Haas once.
So frames, you had a different tool frame for this guy, didn't you?
Yeah, I didn't want to disrupt the other configuration.
But you swear, you were just telling me we're never using the other configuration again.
Oh yeah, sure.
So it's trying to go down 20 millimeters too far.
Yeah.
No,
You changed something to big flipping?
Yeah, like big, like I hope this is going to be a highly edited video.
We'll edit it.
Yeah.
Are there absolute encoders on that joint axes, or are they non-absolute?
What's that?
Are the encoders absolute? Like if you...
Yeah.
Okay, so it knows exactly where it is at all times.
Yeah.
It doesn't have to like go through a homing sequence and then get relevant or relative encoder count.
Yep. Open the gripper. Okay. And then we wanted to try find and grasp. Okay. Great.
Do you want me to capture the workpiece?
No, we're good. That's the entire find and grasp routine there. Right. All right. So if we look down here, we've run through the sanity check routine.
Yeah.
We ran through find and grasp. The very next one that we're going to be looking here is move into mill. And we do have a bigger gripper in there, although I assume move into mill is going to work.
So this will need to open the auto door then, right?
Yeah, you want to take a look at the move.
Does the mill control the auto door, or does the robot control the auto door?
The robot does.
Okay.
So move into mill moves joint move to a post check position. Oh, like if we were checking the part with that proc sensor.
Okay.
Right? And then we open the door, then we move to a location
Pre-window
called
and
pre-window
post-window.
and post-window, and that's it. So let's give it a shot, shall we? Move into mill. Keep your fingers crossed.
That's fast.
Yeah, interestingly, I've got a better routine for that.
We didn't trigger the safety, did we? The cans?
Oh, yeah, I think we did. That's okay.
Is it the tape? Is that what it's watching for? The cans?
No.
Lacquer? Okay.
It is. It's watching me, though. I keep tripping it, and it's pausing.
Oh, you are approaching us. Have I? In my simulation, I have the robot much closer, and I need to rotate the gripper beforehand.
Okay. So that seemed to work. We're okay there. What's next in our little program here? Next was pick from op1 vice. And this is going to be an interesting one here because what we're essentially trying to do is grab this workpiece out of that vice, right? And so depending on where our user frames are, this guy is going to apply the tool frame for this flipping gripper. It's going to move into position, and this mill's going to move in too. And so this one is one where I'm going to be, you can see the mill's moving, the robot's moving, and I'm gonna stop things right there because that was
close.
That was too close. All right. So, if I remember correctly, the user frame for all these, and I said like user frames you can configure in any way you want. And for this, I really wanted Z always to be up. I always wanted 0, 0, 0 to be where I'm grabbing or releasing the thing, right?
Okay.
So here's what I'm going to do with this guy, is I'm going to jog. First thing I'm going to do is jog up a little bit, right? Oh, pretty slow, for good reason too. Boy, we're, okay. So you can see we're way over there. So on the robot, I'm going to move back quite a bit. And that, to me, looks about ish correct. So we're way off of where we used to be. The other thing I'm going to need to do is close that gripper.
So what I learned recently about is the value of this tight integration. So when I'm designing like the gripper assembly, and I do a bunch of simulation to fit the window, you oftentimes need to align your like machine table accordingly. So like we do flipping inside the machine. So in this pose, we move the table slightly, and then we will move it slightly different, so that the robot never collides with the narrow window, narrow door. And if you don't have this tight integration, and you want to step through the program and do some increments, it will be much more error prone. And here in the program, we can just say, okay, move mill to a spot, which is very convenient for me to reach with the robot.
So
yeah, that is nice.
So we've got this user frame that we're going to train, and we're very close to having this thing deposited, right? But we're not actually in the right spot. And so I'm going to jog us until we're in the right spot. And I think the right spot, AJ, I'm going to have you come in and look at this, okay? Pop your head in there, and I promise not to cut it off with the robot. So I think I got roughly centered from like XY position.
Okay.
But what I don't like is my, this would be the B-axis rotation. You see that?
So would you give it some preload pressing down, or try to leave it a little bit above the surface?
Right there. Well, it depends on what you're doing. With this guy, we're actually sliding that whole thing in under the gripper, right? And so I just want it right there, because we can always settle it in the vise or something, but we're picking it up right now, so I don't care if it's preloaded or not. I don't really want it preloaded.
We're going up. That makes sense.
So I've got it, I think, roughly where I want it. The C-axis rotation, everything else looks pretty good. So I'm going to say that's good. So I'm going to go ahead and zero out this user frame right where I want it. roughly where we are. You know, I don't think we can get all the way out there. Is that gripper not as far out as the other one was?
Far out?
I can't, here's why I can't get out there. Right? I think we're getting real close to, I can't go any further than that. It's trying to go, but it's, that's at the end.
Yeah, it's slightly closer to the, it's meant to be used with a new table. So I have a solution. We can grab.
So here's why, right? X, it would go.
Yeah.
It would go to -20, right? These things would work if I were.
I see.
Now I can go. This is where it was trying to go to, except further out in X. That's why it said no.
Are we like maximal? Are we maxing out the X machine?
We could change that.
We should change the machine X. Yeah.
It's just not quite getting as far this way as they want. So this came up because your gripper got shorter, right? Or
we used to use, when we put this giant gripper in, Jakob used to have the gripper positioned out here,
yeah,
and he moved it closer in. I assume because he wanted a more compact gripper.
Yes. So this proves very beneficial when you want to optimize your table area. If you have a big offset, you will be losing of your grasping area. But in this case, offset is actually desired.
yeah.
So this offset, this gripper is designed for a table which will bring with mounting holes that are 15 centimeters closer to the robot enclosure.
The table the robot is sitting on, not the machine table.
The robot is essentially.
Yeah, it's half a mile out the side. How far can the spindle get towards the edge of the table?
We could move the vise over a little bit that way. It would still work.
Maybe you want Rocky to make I can drill new holes in the table to really reproduce the table setup.
He wants to move the robot.
New holes in the table.
Oh, for the robot, yes. I would actually love to do that, Jakob. I want to put it.
We kind of have to do that because we have a long lead time on the new table and.
Yeah, no, we should do that. I like that solution the best. And then we can retrain these through frames. Yeah.
Minutes.
How about this?
Just.
How about this? How about this? Let's do this. You wanted to talk more about Tormach. It's 4:30 now. I could talk a little bit more until 5 or 5:30 if you're that free. Jakob, if you.
Whoa, you have a TSC chip fan.
No, that's
No?
That's just it blowing coolant off of stuff.
Oh, okay.
Yeah.
Huh. It looks like there was a stream going straight down.
No, I think it's just sucking stuff out of the nozzles.
Okay.
Little Venturi effect going on.
Yeah. That's cool. So
the cycle's done. Probably what you want to do is come over here if you
okay.
want to see what's going on in here. So this guy's going to come in. The robot's going to move into place. It does a short move. It checks the torques on the robot, make sure nothing collided. If it had, it would have stopped the program. Moves into position. It's going to grab this workpiece with that really long gripper. That's the one that flips things over. It'll drop off the raw workpiece that it picked earlier. Close the vise on that. Now it's going to move over, grab the finished workpiece. A little bouncy because the table's the new holes we drilled in the table earlier today. It'll drop this guy off, close that, and we'll use the mill to move out of the way.
and the robot's commanding the mill, right?
Yeah, the robot's got a bunch of MDI commands in there that are telling it what to do. And then it's going to get its butt out of the way. Door will close. And the robot will drop off the other workpiece.
And the mill's already moving.
The mill's already moving, yeah. And the robot's going to sit here. It's going to drop off the other workpiece. And it's going to go find the next one, pick it up, and repeat the process. Now, I wish that we had the vision system working for you, because then it'd just pick up one of any number of workpieces that we set on the table. This is my hack around that right now, is we're just tossing some stuff in place for you. So, meanwhile, the mill's off probing, making sure everything's in position. Then it's going to probe it to get an accurate position as well. And we could skip some of the probing moves if we had a regrasping station. The vision guided grasping, Jakob, is good to about 1 millimeter. I mean, it's perfect when it comes to the centering of the part, right? Like, it's always going to grab this in the center.
Yeah.
But it might pick up this to within 1 millimeter, plus or minus, depending on the size of the workpiece and the lighting and all the rest of that stuff, right? And so we could have a regrasping station where we put it down and we grab it exactly in the middle. Instead, we're just deciding we're going to probe both sides.
Yeah.
The neat thing is, and we haven't bothered to implement it because it's so repeatable. Even if you're off by 1 millimeter, it's pretty repeatably off by 1 millimeter. But what we could do is when we probe, we could tell the robot, change your pick location next time, because we just probed it and we know it's here.
Yeah.
We haven't done that, but we could, which would be super cool. We do the engraving first, and then we come in and do the rest of it.
You start with the engraving before you face mill it?
Yeah.
You clean off the burr?
Yeah, it ends up making nice. And this is, we did the fancy engraving for the show, because if we don't do like all those little letters and those lines, then it gets done in 2 minutes. And
Then you make a lot of soft jaws?
you want some soft jaws? We bought a whole bunch, so we've not found a great supplier for soft jaws. Like, we can buy we only get a margin on monster jaws. Like, we're buying monster jaws and selling them to you for what you can buy monster jaws for, right? So we're going to go ahead and make a few hundred of these and sell them. Marketing / production effort on our part.
That makes sense.
But we're going to do a different demo at INTS just because there's not a lot of metal removal
Yeah.
in this one, and so.
And that's what people at IMTS want. Give us the chips.
I mean, I don't know if this makes the YouTube cut, but I'll be honest. I feel like at IMTS there are so many 3-axis milling machines doing amazing stuff that it really doesn't matter. Crazy metal removal in aluminum is not something that I think impresses people at IMTS. So having the robot there using a vision system to find any workpiece that's set on the table by somebody and throw it into the mill all day long in an automated fashion, that's what I'm really passionate about showing off. I think that'll be a game changer, especially when the price tag of, you know, this thing with all the bells and whistles and that thing with all the bells and whistles is like 80 grand. I think some people will see that and go, wow, I could put that in my garage.
Yep.
And I could start taking jobs that have, you know, a 2,000 part count, and I could be competitive with the big shops just because I can run this thing.
For like cheaper than a VF2.
What we're shooting for. Yeah, VF2 without a robot.
Yeah. Yeah, cheaper than a VF2 without a robot.
Yeah. And, you know, we'll probably go through the whole 9 yards at IMTS, and we'll put like a wash down station and rinse stuff off and just have it ready to go.
That the robot will operate?
Yeah. Yeah.
Awesome.
Dunk it in a bucket or something.
Have you ever like ran a bunch of these and tracked the width of them over time or the dimensions? Do you know how stable is it?
Caliper or micrometer? You know, tool wear dependent is basically the only thing that's going to change that. And because we have the probe, we could, if we wanted to, do an in-situation inspection and then change a wear offset. You know, use cutter comp and try to hit something super precise. This part doesn't really
No, it doesn't need it.
require that, you know. The part that we are going to be doing at IMTS is a much larger part. That's what all this stock here is for. And we're doing the motor mount for the Micro Arc 6. So the fourth axis has a servo motor inside, and it's a reasonable tolerance item. And we're going to be cranking those out of the show. And we'll have a few years supply. I'm not sure what it's supposed to be, but we'll wait till this next one comes out and you can measure them both. You're welcome, Elizabeth, if you want to get up close. This one I think is an old one. That's, I mean,
I'm
go ahead and check it, but that's, find you one that was made today. I can tell because the hatching was done for the show. Now we're not doing the hatching on these ones as they're coming out.
Currently,
So I'm not even sure
taking your paper towel.
I'm not
There you
even
go.
sure it's the same tool that was used for those two.
Now, with caliper accuracy, at least, they're all dead nuts, so. So yeah, pretty good.
I mean, you know, how many of these did we make at Automate? 250. Yeah. So I don't think we didn't change end mills, did we?
I mean, it's aluminum. You can run tools until they fall apart. That's cool. Man, I need to run soft draws. I should have you guys.
Did you talk about the probing at all with you or no?
A little bit. I mean, we're probing. The first thing we do is a check just to make sure the thing's actually in the vise and not like at some cattywampus angle. And if it weren't in the vise, it would just shut the whole thing down. The robot and the mill would both.
Say, is that through spindle?
Yeah.
I swear there's something going on with the fan when it first turns on. It's wild.
I think it's just the coolant ring has got a fair amount of coolant in it. We have a check valve in the system, so when it shuts off, it doesn't drain all the way down because then it takes another couple seconds to get going again. But I think there's enough suction from the fan that it's pulling a vacuum on that check valve.
It must be.
I think you're right.
We could use an air knife too. I mean, the fan is left over because we didn't bring flood coolant to Automate. We just brought-
okay.
Yeah, so this blue tape is going to be the boost we have at IMTS.
I wondered about that. Okay.
And we'll probably have the machine as far over in this corner as possible. The robot table is going to get it's going to be pushed back quite a bit, the new one, and it'll have a little wing to it. And then, are we bringing an AF50?
I keep waiting for it to switch to the fan so I can show you what I mean. I wonder if it's some effect from the kind of, like it has a little bit of a bullet shape on the front of it. I wonder if that's acting like a nozzle or something.
No, because it would have to have coolant flowing through it, and it doesn't. The pull stud's solid, everything.
I believe you, I believe you. I just want you to know that I'm not crazy, and it looks like it for a second.
Where'd you find this crazy guy?
I promise I'm not that crazy.
All right, AJ, I apologize. I've got a
Nope, you're fine.
2:30 that I've got to get to. You guys are, when are you heading back?
See, there's like,
It does look like
it does.
He's not crazy.
There's definitely a jet.
Yeah.
Why?
Gotta ask Jason. I don't know.
That's pretty funny.
Is it doing something? Am I not?
Well, the pump's on. I'm with you.
Well, it's not doing anything now.
Yeah.
Well, that's just power.
I heard it.
I heard it turn on. Yeah.
So we are terrible vloggers. We went to Tormach and now we're done for the day. I guess we might be able to put some of the in-between footage, but that's mostly going to end up in other videos. It was a lot of fun. At least I had fun. Did you have fun? Mm-hmm. I had fun. We hung out with their CEO, Rogi? Is that
Daniel Rogi.
Daniel Rogi. We hung out with him most of the day and got to hang out with Norman some and play with the robot, the ZA6 or whatever it is, and it's a pretty cool robot. So
And a really nice company.
And a nice company. The robots are cool. The people are fine.
Down people.
And yeah, I had a lot of fun. We'll be back tomorrow to actually make some chips if I ever actually design the thing that I'm supposed to be making. Now what are we doing?
Unknown. Potentially dinner.
We're also going to go pick up her new sourdough starter.
Yes.
We found sourdough starter on Facebook Marketplace, so she can still make her bread for her customer. And we'll get food. He gave us a lot of other things we can do, but I don't think we're actually going to do any of those, right?
I don't know. The park sounded kind of nice.
The park does sound nice. Can I design my thing in the park?
I mean, all the things sounded nice. I just don't know if we're going to have time for all of them.
Bye. Tormach day 2. We should be doing some actual machining today. Yesterday we mostly just played with the robot. My wife is playing with her sourdough in the parking lot because she is who she is. We just spent like half an hour at a coffee shop. I had intended to design something a little bit more complex to make today, but I just never got time. So I quickly drew up a desk organizer kind of thing. But should still be fun to make. Of it actually cutting. I am at Tormach headquarters right now. I'm sitting on the new 1500 MX and we're gonna make some parts on it. Actually, specifically, we're gonna make part on it. We're gonna be making it out of this chunk of aluminum. And I was about to show you the 3D model, but I don't have it. It's my friend Norman. He works at Tormach and he's gonna be, well, I was about to say he's gonna be helping me run the machine. He's probably gonna be running the machine and I will be here. What is this one for? It's like a set screw holder with no set screw.
It's the Diamond Drag engraver.
Ah.
I stole the spring out of that one to double up the spring in the one that's up there.
Oh, we're using that for the engraving?
I don't know about this part. That's what I've been using on another part, though.
Okay. I was expecting a ball mill.
I don't know if we have any small enough here because I broke mine.
You can use that. Is that a drill?
That's a
Or is
drill
that
mill.
chamfer tool? Yeah, drill mill works.
Well, we're gonna face it off anyway, so yeah. Fusion.
What's this holder for?
That's just a modular one. So it's just M8 or
Oh,
whatever.
so you
on the
could
end of
put,
it.
okay.
Yeah. I really like those, especially for like insert mills. Well, you have to use an insert mill with them.
Is this what we're using for the box?
Yeah.
Nice. This one is for calibrating the tool setter. Does that ship with the probe set, or do you have to buy one?
Comes with the probe kit.
Nice. It's way fancier than a gauge pin and a ER holder.
Yep.
This is the design. I made it this morning while having my third cup of coffee.
I changed your internal radii.
That's fine. Did you make it a little bit over a 1/4 inch so you want to
Yeah.
get the, yeah, that makes sense. Wasn't thinking about that. I guess I need 4 cups of coffee before I think that far ahead. Oh, the backside was designed for a 1/4 inch end mill, I think. Plus a little bit of a cheeky engraving. Focus. Focus. Focus.
You want me to do it again?
No, it's fine. I'm a great cameraman.
Literally 2 weeks before we launched, we went through speed the damn tool changer up, and we cut like 5 seconds out of it.
But you couldn't get 10. Actually, there's probably not even 5 seconds left.
It's 8.5 to like 9.5 seconds.
Okay. What do the numbers mean? Do they have any semblance on reality? Is it like millimeters of travel or something like that?
The convention started so long ago that there are actually 2 different theories.
Theories about the name.
Yeah. The one that Rogi subscribes to, and it's probably the right one, is it's spindle power in watts.
Okay. That checks out.
And
At least
some
up to
people
the
say
1100?
y-axis travel for some reason. I don't know where that comes from.
So 400 watts for the PCNC makes sense. 700 for the 770.
Yep.
1100 watts feels light for the 1100 though.
It's a little low, but I mean,
Okay.
if you're trying to keep in the pattern or whatever.
Yeah, it isn't the 1500 like twice the 1100?
Yeah. So the 1100 MX is 2 horsepower, 1500 is 4.
And it's like 740 watts per horsepower?
746.
Yeah. I remember random numbers from engineering school a long time ago. Oh, that was a photo instead of a video. Man, I am like straight grandmother mode on my camera right now. Is the tool changer design, other than scale, exactly the same as it was?
In basic concept, it is. You've got a motor, gearbox, and then tray.
Okay.
But the motor is a stepper motor on the 1100s and 770s. This is just another EtherCAT servo.
And pneumatic cylinder to move it in and out.
Yep.
Looks like a bigger cylinder. On the old ones,
It is.
was the sensors weren't on the cylinder itself.
Yeah, I complained about that a lot. G55.
More B-roll.
You're- It does still kind of shake stuff.
I don't know what the smoothing settings are on right now. I generally just put everything on L3 and leave it, which is fairly aggressive. I haven't had time to actually.
If
I'll look at them in a little bit. Once
if
this
I
is done.
open the door, will it stop?
You can't open the door.
I can't open the door.
If the LED is not lit, you can't open the door.
Interesting. Have you been tempted to override the door safety thing yet?
You use an Allen key and you can trip it. The probing screen especially is the main reason. I'll show you once this is done. All right, so LED's on, now you can open the door. And this goes away. It did for the ATC screen. They fixed that one, and they will for the probing screen. I just don't know exactly when. It's our game of, well, we need to be safe for the CE regulations.
I have a magnet on my machine right next to the magnetic door sensor thingy, so that if I ever need to do anything with the door open, I just pop that on.
Yeah, but this is just a little bar, and then there's a catch in there.
Okay.
So, really simple.
So it's a physical switch.
Yeah. I'll show you smoothing, because this is something I want you to play with a lot. So we've always had G64, which is just allow some amount of corner rounding, which we default to 5,000, so nobody ever messes with. So that's still in there, but what we've added is M59, which gives you the smoothing time, acceleration, and your tolerance.
Okay.
So acceleration is the easiest one to figure out, because that's just, if it's 1, accelerate as fast as you can. If it's 0.9, go at 90%. Smoothing time is every millisecond, if there's a new motion segment, we're basically saying, within X time period, curve those motion segments more.
Okay.
Well, not curve them. Your acceleration is staying within a tighter range, which is just either keeping you fast or keeping you slow, depending on whatever your current speed is. And then your tolerance is in between moves, how far away are you able to go, versus the normal G64 is just at a given point, how much can you round it? But in that point, how much can you round it is new there.
What is naive cam?
That one I don't really understand very well. That's been part of G64, and Rob has tried to explain it to me a bunch of times, but I've never seen it actually do anything. So I ignore it.
Is this in all Path Pilots now? This menu?
Not right now.
Okay.
Once we go to 212, it will be in every machine. You're not really going to see much effect on machines that aren't EtherCAD, but it'll be there.
What are the different coolant buttons? Is that like through tool? What's the...
We have tooltips.
Oh yeah, flood, mist.
Yeah.
And then up here you can change where the coolant comes out of?
Well, this is just turn on or turn off TSC if you have it. And then washdown is...
Does washdown turn on by default ever, or?
It's M-code activated, which I don't have in the program.
Is it built
right now.
into the post?
Not right now, but it will be.
Does this one have the chip conveyor?
No, this is just chip pins. We've only got the one prototype right now.
Oh, there's the back washdown is running.
I feel like you can see more on the left side.
Probably.
Why does that sound so much better than any machine I've ever ran before? This window is going to get replaced a lot, I suspect. What? You're just sandblasting it. Is this the side? Yeah, this is the side the auto door's on.
Yeah.
Chips are coming through the window gap.
Yeah, I got hit with one.
Oh, Davey. So this is 150 inches a minute, 1 inch wide, 80 thou deep.
Not doing that on my Haas.
100% spindle load.
Oh, that's cool. Is that a new path pilot? Like for everybody?
No,
Whoa.
that, we can only do that on EtherCAT machines.
Ah. You don't have a vibration sensor in here at all, do you?
No.
I really want the Kern oscilloscope thing, where I can compare vibration to spindle speed.
I don't know if we could get that from the encoder somehow. Because we can track following error.
You could, yeah, you could get spindle load, no problem. You could get feed rates. You could get spindle RPM. But yeah, I think you would need some extra sensor to get the vibration.
Maybe.
But that would be so cool.
Well, I know Haas has some kind of vibration meter on their machines, but I don't think they have a dedicated sensor for it.
I don't know. Mine definitely doesn't. I still haven't gotten a successful tool change. Go back to the side. I know the chip washdown and chip management shouldn't be the most exciting part of this machine to me, but it really is.
Yeah. It's definitely nice.
All right, what speeds and feeds are you running?
Don't remember.
Well, 113 inches a minute, 8,300 RPM.
It's a max step down of 1 1/4. I know.
1 1/4 inch step down. You're only at 50% spindle load.
Yeah, 113 inches a minute, 1 1/4 max step down, 50 thou with the cut.
I feel like you could do a lot more.
I could. It's just this being a long tool, I didn't want to push the width.
Yeah.
But I mean, I can crank the feed rate up.
Does your spindle meter go over 100%?
Goes up to 300.
300.
You can do
the
300
spindle
for
go up to
about
300?
Oh, it'll go to 300 for about half a second, and then it's going to fault out. But we can do 100% continuously, 125 for half an hour, 150 for about 5 minutes, 200 for a minute and a half or a minute, I forget. It's a sliding scale, so
Yeah.
You can take advantage of that depending on how you're programming. Like if you're face milling at 200 inches a minute, if you're just doing it in one direction only, that break to retract will extend the amount of time that you can do that cut for. So it's all in your strategy.
Is the black tube your mist coolant?
Yeah.
Okay. It had very little
He has it
effect.
turned
with
way
the
down
coolant.
right now.
Okay.
But we have coolant pressure.
You have coolant pressure, yeah. With all of the washdown on.
Yeah.
Does it
Washdown
even-
is on a separate pump.
Okay. I was about to say, does it even make a difference to the... Do you have a coolant hose on this thing? Like for manual washdown?
Yep. Right inside there.
Oh, it's inside. Oh, it's so smart. Does that run on that pump or the...
That runs on washdown. So if you want to use the washdown gun, you flip that red lever.
Okay.
And that'll turn it off for the coolant range so you don't get splashed, and then you can wash down the machine.
Nice.
And then your air gun too. This is your end mill though.
I don't care. Is that why Rogie can't run?
No, this is the one I had on M1. This is the 2-inch, half-inch long, or half-inch, 2-inch long.
You don't have any provisions to bolt this thing down, do you?
No. It's fairly simple to do if you want to. You just need a toe clamp, essentially, but you can do that on the plate.
Okay. I think it might actually benefit from it.
Maybe.
You don't have the swirling on, do you?
On rough, that's why it's not thud, 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 thud.
It's still doing it a little bit, though.
A little bit, yeah.
Smoothing up a little bit more.
Yeah.
It's all programmable smoothing, so you can adjust all those settings. You can make it look like it's going to walk across the floor, or you can have it be glass smoothing.
I took the Speedio manuals from Easton,
Leave it on.
and I gave them to Rob and said, give me M298.
Nice. I think you actually need to bolt this thing down. I think it would actually help with the cut. Because it's moving more than I would think it should.
The frame doesn't move. It's the enclosure that does.
Yeah, but that vibration's coming from somewhere.
It's the table whipping back and forth. That's still translated to the machine itself.
I think that's worth testing.
I don't see any reason not to.
Everyone I've ever talked to who's bolted down the machine has been like, it makes a way bigger difference than you would think, even on machines that don't theoretically need to be bolted down.
I saw Brad on Discord saying he bolted down his mini mill.
Yeah. I would actually be able to recycle my chips with one of these because it would be easy to clean out.
Yeah.
I change material so often I don't normally bother with it. This hose, I just moved it and let a bunch out. This is building a log jam of chips.
It should be underneath it.
Yeah. Have you ever considered like extending these out a little more or something? This seems like a recipe for eventual overflows, unless you come and do that.
Yep, it does. We've been trying out a couple different versions. One that like goes out in an angle, and deeper ones, which does help. I don't think those are the right way to go. I think we just need to get a rubber flat here and make the whole basket taller.
Yeah. A little flare on the end might help too.
Yeah, that's what we've tried.
Okay.
And it does help.
How much coolant does it hold?
35 gallons.
35?
Yep.
Are you guys going to start selling pails at Qualichem?
What's that?
Are you going to start selling pails at Qualichem?
It's actually a good question that nobody's thought of.
You should do that. Especially because I still buy my coolant from you guys.
Yeah. You don't want to talk to your local distributor?
I tried and they were annoying.
Yeah.
And it wasn't cheaper, or it wasn't notably cheaper. It was like save $20 over 5 gallons.
Yeah, we're pretty well priced on Qualichem.
Is the auto door on your 1100 over in the other room public knowledge yet, or is that still?
I don't know, actually.
Okay.
It's a prototype, so.
Because that's cool. That's something I hadn't even thought about. I'd only thought about automation on this machine, but 1100s are perfectly capable.
Depends. Chip evacuation especially is,
Yeah.
you're gonna run into that really quickly.
Depends on the parts you're making.
Right, if it's really tiny stuff with not much material removal.
Yep.
Yeah.
Like my
Work.
carabiners, for example.
Yeah. Oh, shit. I should have showed you that before I started it.
This is the ball mill.
Yep.
You have pretty major stair steps in there.
Yep. There's power going some.
I'm really curious if those stair steps are going to show up in the finish. I'll be supremely impressed if they don't.
Whatever, so make mine.
It's a really small step over, so maybe not.
Do you have any sort of provision to wash off the probe tip?
No.
Do you think you could like add a nozzle? And when I say you, I mean a user at this point, not necessarily Tormach. Do you think a user could add a nozzle from the washdown to hit the
When
probe
you say
tip?
probe tip, spindle probe or ETS?
The tool setter, yeah.
I mean, sure, you could do it. I have to use the USB I/O module.
Okay. Well, I was thinking you could just plumb something directly from there, and just whenever the washdown turns on, it washes it off.
Right. Well, you could do that. Just tie the solenoid into the
You could do that.
pump signal.
Does this ship with mist coolant, or is that an add-on
It's an option.
option?
Blood coolant's an option too.
Everybody's gonna get flood coolant.
No.
Really?
These two haven't.
Really?
Yeah. Well,
Why?
one of them, the guy was shoving it in his garage and he didn't have room for the coolant tank. The other one, they're just demolding plastic injection molded parts, so they don't need it. And
Okay, fair enough.
they will pick up the machine and move it like once a week.
Really?
To a different injection molding machine.
That's so funny.
They were the customer I went and talked with yesterday because they've got two 1100 MXs and now the 1500, and they've got UR robots on each of them.
Huh.
But yeah, like they said, sometimes it'll just be a run that lasts a day, and then they'll move the machine to a different machine.
It's so funny. It's a good machine for it.
Yeah, the 1100s they said they put on casters.
You say my office mill has the option of casters,
Yeah.
which I still find funny.
Are they
but
the like leveling casters or whatever?
I think so.
Okay, that makes sense.
And it's an option. I don't have it.
Pallet jack.
Yeah, exactly. Does it... Wait. Are those filters? Those are filters. Does it come with filtering standard with the coolant?
You get the filter with the washdown kit, or the filter with the or filter with the flood coolant kit, filter with the washdown kit. So
Nice.
each one has its own. If you get TSC, there's the third one that you add as well.
Okay. And is that the hole for the third pump over there? Would that be TSC?
No. So TSC is in a separate enclosure. It'll basically sit underneath the left side of the machine, and then your hoses will come back here. The filter and pickup mount on the flood coolant tank.
What pressure is the TSC?
400.
400? Okay.
We've got it on the automate machine,
Ooh, okay.
so we can turn that on. It is instant.
Is
That
it?
is built up. Yeah. Which I'm really, really happy about that.
How much pressure can all the internal parts take? Someone's
Area
gonna
could
hook
go
it
up to 1,000.
Someone's gonna do the Speedio hack with like a pressure washer or whatever
Yep.
it is.
Yeah, that front is an area where I have to play the corporate. I work in tech support. Point of
Void in warranty, yada yada yada.
yeah. Like I straight up told our supply chain team we are not selling the rotary union as a separate component. Of course, that's something I do myself, but
Yeah.
do as I say, not as I do.
Someone's gonna do it.
Oh yeah, eventually. Just don't call me when it blows up your spindle.
What toolpath are you using for those? Is that parallel?
Parallel, yeah. I don't know why. That's pretty much the only thing I use with this tool. It works.
And did you put a deburr toolpath on the?
Yeah.
Okay. All the slopey edges. What are your thoughts on the Saunders fixture plate for this machine?
I have a love-hate relationship with Saunders fixture plates.
I like them.
I love the idea, but every time I use one, I hate it. Because there's always chips in the tiny little holes. Whatever I have, I'm trying to bolt in, just never fits right. I don't know. But
I use mine all the time.
Yeah.
My complaint is it starts to get really expensive for a machine this size. For
It
something
does.
like the 1100 or the 770, like they're dirt cheap.
right.
The one for my house was like $600, and I got the medium one,
Yeah.
the
Well,
7075 one.
when we got the prototype,
It didn't cover like 8 or 9 inches of the table.
Oh,
because that's the biggest they could go without having a freight shipment.
Ah.
And we all looked at that and said, we understand the logic, but it looks
nah.
weird.
Yeah.
So I'm not even 100% sure, but I think we ended up going with just the full-size one.
You're like
Which-
$2,500 though.
Are
And
they?
that's a 0 point.
Yeah.
So I think
Well, my knockoff Hero was like 400, so it's too competitive of a space.
yeah.
And the puck chuck system just doesn't make sense.
No, it doesn't. It's too expensive.
Yeah.
It could have done well as a cheap shunk, but it ended up being like a more expensive shunk.
Yeah.
I don't know, maybe not more expensive than shunk, but more expensive than a Lang system.
Yeah.
I'm gonna put a Roa on it. The Roa on the Haas, a Roa on this.
Aroa makes the most sense, to me at least. It's the only system where you can have a big chuck and put the tiny thing on there without having any kind of adapter. Well, 3R, but same difference.
And there's so much of it out there used compared to the other systems and knockoff and like,
Yeah, you're not tied into a vendor.
the pull studs aren't that expensive.
They're like $10 if you get the knockoff ones.
I don't know how difficult the pallets are going to be to make. They seem more complicated, but I don't know if that's just.
Well, finding the documentation is kind of a pain. But they specifically say, like, install the feet and then you're supposed to grind them flat or whatever, which I don't know if anybody actually does that. So, probably still works even without it. How many passes did I do?
I was going to say, is there a roughing finishing pass? Because that would take care of your big steps.
Yeah.
Oh, I did 2 depths. Okay. That makes sense.
Out of the people who have bought these machines, how many have taken the bigger micro arc?
I haven't looked at every order. At least 4 or 5 micro arcs, I know for sure.
It's a lot less micro than it was. Now it's
Medium
just an arc.
Yeah. I really wish we did more with rotary tables. Like have a high speed option or high torque option, but
This one doesn't have a brake in it, does it?
no.
Okay.
Don't really need it.
I want you guys to do a trunnion.
I want to do a trunnion.
Every time I talk to Roby, I ask him for that.
So the problem is we can't. Well, we could do a trunnion.
I know it's not easy.
But-
Don't get me wrong. Like, but I want one.
It's easy to do. It's hard to do well.
Fair.
There's some issues with the backside of Pathpilot, specifically the switching between tool center point on and off, which, I mean, we've got Rob. He could figure it out. He's a genius. But there is that software work. I really think we should do a positional 5-axis.
90% of the battle.
Yeah, I was actually kind of pushing for putting it on a 440 first.
Okay.
Just because, one, there's not really any competition there for anything that could machine
No.
steel at least. And two, that just gives us the time to build out the software where we release it, we get a bunch of people testing positional, making sure mechanically it works and electrically, and then we add in simultaneous later.
With the same hardware or with different hardware?
Same hardware.
Okay.
Yeah, positional hardware is the exact same as simultaneous.
Well, again, unless you have brakes.
We wouldn't do brakes. We just do harmonic drives. I don't get why nobody else in the industry uses harmonic drives. Maybe.
I assumed other people did, and it's beyond me.
Nobody I know, anyway.
What are they using? Planetary? Like,
It depends. Like Haas uses like colloidal drives. They originally were using, what was it? Maybe it was just planetary originally on the UMCs, but then they switched to like colloidal drives. Other than that, a lot of people use direct drive or worm gear, roller cam for some of them, but nothing harmonic. And it's such a simple system. It's like housing, motor, harmonic drive.
yeah.
On this one, 2 pulleys and a belt. So I don't know.
What's the through bore?
Like 31 millimeters.
So it's over an inch.
Yeah, over an inch.
That's big. I think you can put an inch bar in it.
Yep.
When you can give it a bar feeder.
Don't give me ideas. I got to do this first.
Ooh. You actually, is that in the plan?
We were talking about it for the IMTS demo, but didn't end up doing it. This is
Hey.
what I wanted to show you.
Okay.
So we're at an M1.
Uh-huh. You can jog at an M1 now?
Yep.
Oh, that's so nice.
I didn't even realize we put that in like 3 versions ago. And Rob just said, yeah, I added that.
That is so nice. Mm-hmm. Does it like go back to a safe position afterwards, or whatever your code says?
Whatever the code says.
So you could theoretically potentially get yourself in trouble.
You could.
Okay.
But in every post that I know of, at least, it's going to tell it to go to G30 at the start of the toolpath anyway.
Well, and you guys control the post, so.
Technically, no.
You aren't
Cam
writing
provider, we don't write any posts.
You don't write any posts?
Nope.
Oh, I thought you guys maintained the posts.
No. Which, maybe for Fusion, that would make sense, but
Yeah.
if we have that policy, then we need to write a post for Fusion. Mastercam, SolidWorks, GibbsCam, whatever flavor we
Wow.
want.
Interesting. Do you like that or not?
Yes and no. I like that I can just say, hey, make this change.
Okay, so you can tell them to add or remove
Yeah.
features. Okay, okay.
Yeah, that's all I do with Bob, is just say, hey, can you make this do that? How do you like deeper?
I haven't used it a ton because I just got the manufacturing extension, but sometimes it's like the only way to get a good deburring toolpath on some parts. I've used it a couple times and it's like gone a little bit too deep, and I've never dug into like, well, was that my settings? Was that the tool length or what?
Most of the time that I've used it, like probably 90% of the time, it's like automatic hole recognition and then just done. And it works great. But like 10% of the time, it's just like, what are you doing? And it's usually like the simplest feature imaginable. I just can't figure out why it won't work. Now granted, I don't know what the hell I'm doing. So.
I've had to try to deburr things that didn't need to be deburred before too.
Yeah.
It did that on the Gridfidity optical comparator parts. It just deburred like a gentle kind of rollover, and it left an ugly mark. Yeah. But again, I kind of wonder if that was because my ball mill tool offset was a little bit off. Because I had recalibrated the tool probe at one point, and so there may have been a mismatch there. Is that it? We done?
Yep.
Dude, that looks great. There's some faceting on the corners, but the finishes are great.
We didn't quite clean it all up yet. We could rerun the 2D contour.
Sure. We didn't have the smoothing settings right on those corners, so it's a little bit faceted. So we're going to rerun that perimeter with different smoothing settings.
Ah. No, that wasn't the problem.
What was the problem?
I didn't do a 2D contour around the outside.
Oh, was that the adaptive?
That's the adaptive.
Never mind. That was the roughing toolpath. We didn't finish the outside. Why are the finishes that good on a roughing toolpath? Why is this so much better than my OM?
Whoops.
Does the post support in-process probing?
The post does, yes. There's one error I know of in the macros itself. It's just the x-axis pocket going in the wrong direction.
So what if we did automatic wear compensation?
That the macros can't do right now.
Okay. That's like my favorite feature. Mostly because I just got it unlocked thanks to the manufacturing extension. I do that on everything.
You should send me an overview video of how that works.
That is on my list.
Good.
Ooh, can you do the probe inspection thingy yet?
I don't know what the probe inspection thingy is.
The probe inspection thingy. Where you use the probe to measure your part and then it spits out a file that comes back into Fusion.
Oh, no. I was asking Bob about that a little bit, and he basically just said, danger, Will Robinson.
Okay.
Apparently, that's a whole separate team of Fusion.
Okay.
Just to handle that, and he basically said the amount of integration you have to have with the machine is insane, and only Haas has done it, or done it well enough.
Okay. My office mill can theoretically do it, but I need $100 in various cables and connectors to get it to talk to my computer.
That sounds dumb.
We good to go?
It's because it's an old machine.
Yeah.
New machines don't have that problem. Oh, video?
Yeah.
Oh my gosh, that's good. Okay, I want one. I want one, Norman, I want one.
It's a little streaky.
Where are you setting your Z0?
I was originally planning on sitting on top of the parallels, but now I don't know if I want to do that.
Because you just loaded the part before you did it?
Yeah, that's why.
Okay.
And I generally don't use parallels at all because they're a pain in the ass and just have step jaws. How can we do this?
I'll just sit on top of this stock. It doesn't really matter if it's 10th out short or whatever.
Are you setting your work coordinate system based off of the unfinished material?
Just to face it.
Okay. And then you're going to come back and probe it?
Yeah.
Okay. Can you do that in process, or?
Yes, you would be able to
Okay.
in the post.
Is that how you have it coded?
No, I just have it as one program, but
Okay.
with option stop, I'll just stop it. Actually, the radii is going to be an issue.
Oh, with your probing routine?
Yeah.
You might have to do. Do you have one where you start over the center of a boss and boop and then boop?
If I go to a dev version, yes.
Okay.
I was testing
Normally
that.
I don't like that routine, but this does make sense.
I'm actually kind of curious what your thoughts on it would be. If I'll load that after we machine the top off.
Okay.
I increased the depth of cut for the facing.
Nice.
It's 110 thou deep.
You're at 150% spindle load?
We gotta close up those gaps. It's like 2 inches on the left and right side. I asked for brushes. Engineering didn't like that for some reason.
Should be pretty close. There's only a little pocket left. Plus all of our engravings.
Yeah, it's at least 20 minutes. Should we finish it after lunch?
Sure. Did you get the engraving on the bottom?
Uh,
It was probably in a
no.
sketch that I had hidden.
I didn't do anything with the engraving.
You didn't see the sketch I had hidden?
Well, I saw the sketch. I just didn't cam op 3 at all.
Well, there's an engraving on the bottom. It goes underneath where the cork would go.
Engraving in this op.
Yeah.
Yeah,
In the sketch that was
I ignored
hidden.
that. I saw it when you pulled it up the first time, but I just didn't do anything.
We need to add that.
Need is relative.
All right. What tool numbers?
800? I don't know. I don't usually use this tool.
800.
I segment my tool numbers. Like one to 100 is usually insert tools, and all the 200s are like aluminum tools, 300s are steel, so on and so forth.
Makes
Which,
sense.
if I ever go to a different control, is going to be kind of a pain. But
Yeah.
I got 1,000 offsets, so I'll use them.
I've got 20, which is definitely restricted. Well, 19 because one of them is the probe.
Yeah. Yeah, it's something that on speedios and robo drills always annoyed me. That it's just like 1 through 21 or 1 through 14. I mean, I have to have 14 numbers, but why does it have to be 1 through 14?
Are you using parallel for this?
Yeah.
Interesting.
Parallel is pretty much all I do with this tool.
Okay. I would use the contour. Contours get a little bit funny at the top of fillet sometimes, but
Yeah. I'm doing a pass at 45 degrees this way, and then a pass.
that's what I
opposite.
figured. Though it might look kind of cool if you only did one, but
Maybe. Like really heavily went into brand ambassadors for YouTube for like 3 or 4 years. But that was mostly with Lori, who was she used to be our marketing manager. And then she left. I don't know where she ended up. And that just kind of died after Lori left. And we really hadn't picked it up. I think some of it was we just didn't really see a return from a lot of the ambassadors.
I have a hard time imagining that because everybody knows about Tormach.
Everybody knows about Tormach, but did that translate into sales?
I bet it translated into far more sales than you think. Because, for example, my
Probably.
sale, you would have never, I bought 2 1100s from you guys, and you would have never been able to track those back to anybody on YouTube.
That's the problem.
But it's 100% because of people on YouTube.
Yes, we can't attribute it to it
Yeah.
really at all. So we don't even know if it's worth it. Like the call that I just had yesterday with that company loading their 1100s and the 1500. They said that they first saw the machine from one of Shane's videos.
Stuff made here?
Yeah.
Yeah.
But we had no idea about that.
Yeah.
Like we know a lot of our web traffic comes from Shane, but we can't
Oh, really?
track that web traffic. Well, it used to anyway.
Okay.
We can't track that to
When he makes
that bought a
videos.
machine or whatever. Yeah.
You need to tell him to make more videos. If you could just give him a machine so he keeps making more videos, that would be great. I'd really appreciate it. Is it just me, or is the number of YouTubers making machining videos down drastically from 3 years ago?
It seems like it, yeah.
Because Saunders is basically gone. Grimsmo has made a couple recently, but he's been basically gone.
Well, the videos that Grimsmo's doing now are mostly like it's not about machining at all. It's
Yeah.
just I'm making a thing, and it could be whittling or whatever. But yeah, it does seem like the whole YouTube side of machining has died down a lot, and I feel like a lot of that was buoyed up by Saunders. And now that he's mostly out of it, like all the other smaller guys just seem to have given up too. I don't know.
My theory is that there was kind of a cohort of machinists / YouTubers that all came up at the same time. And then they all kind of got to the point where YouTube just wasn't their focus anymore at about the same time. I think that happened with Grimsmo. I think that happened with Saunders.
Seems kind of like it.
I'm trying to think of other people, but
Peter Stanton too, Edge Precision.
yeah.
He's still making videos, but he's getting close to the point of he's going to retire or sell off the business.
He's the great example of a really good machinist who's okay at making videos.
Yeah.
Saunders was both good at making videos and good at machining, or at least pretty good at both. Maybe not like stellar at either, but he was good at both.
I wouldn't say he was great at either one of those. He was great at explaining what he was doing.
Yes. Which is not something most machinists are good at doing.
No.
There's a parallel on the table. We probably don't need that anymore.
Yeah, we finished the roughing.
But
I can't tell for sure if the other one's even in there.
But again, there's Grimsmo, who was, I don't know how good at machining he is, honestly. He does really fancy stuff through like banging his head against it, but
I don't think Grimsmo is a good machinist. I think he gets good results, but he has a terrible process.
But he's, again, his videos were good. He's good at explaining things. He's very charismatic, like.
And he's excited about what he's doing, and people just get drawn to that.
I mean, other than that, like, I don't know. There's a couple small channels that like dabble in a bunch of different things. Like they'll do woodworking projects, but like they have a 440 or something.
Yeah, that's a lot of what our brand ambassadors ended up with.
Yeah.
Like they make a couple videos that are related to machining, but they have a broader appeal of whatever project they're doing.
Which, to be fair, is probably the smart way of building a large YouTube channel. I think there's a reason that happens.
Yeah. Yeah, it's all about the personality.
Yeah.
There's a lot too of like lowest common denominator of who you're trying to reach.
Yeah.
So.
Yeah, that's kind of my theory with my videos, is to not dumb them down very much, because there's so much of that on YouTube. Like, I'll still try to explain things in a way that anybody will understand, but I'm not like gonna do some stupid simple project just because I know it'll do well because it's a simple project.
Well, I feel like you kind of have like there's nobody that really is going through like, hey, this is the part I'm making. I need it done today.
Yeah. That's just because I'm bad at scheduling.
Well, a little bit, but a lot of the guys, like, there's so much in the industry that people just can't / don't share because it's under NDA. And you kind of have the same thing with Xometry, but you're trying to get around it. And a lot of people don't even try. They just say, nobody can ever see this. I don't know. I like it. There's an aspect, too, of a lot of people like to make fun of you of showing how many mistakes you're making.
Yeah.
Because they don't want to admit they make the same number of mistakes. They just don't show people.
I think that's why people like my videos. It's because like I do dumb things and like they're like, oh yeah, I did a dumb thing once.
Yeah. Everybody
I don't
makes
mind showing
mistakes.
it. Yeah. Yeah, I don't have like, because I'm doing all Xometry work, there is no obligation for me to look super professional to customers. Like, because it's not a marketing tool for me. And I don't know, I have gotten a couple random jobs from videos, but like it's not something that I count on. Like it's not something that I'm planning for.
Yeah.
Can we deburr that lip? Oh, let's do that when we add the engraving.
Yeah, we can do that.
Even when I had a machine that supported it, I never used tool numbers this high.
Really?
And I find it funny.
I can open the door.
2 thou feet per tooth. Does that seem reasonable?
For the ball mill?
Yeah.
Yeah.
Okay.
I usually run it at 5.
Wow, I don't run my ball mills fast enough. Okay.
I don't know why, but I default to 100 inches a minute for aluminum and 200 inches a minute for steel with that tool. All right, gotta touch this tool off. You made this 800, right?
Yeah, probably. Yes, it's 800. I did model it as a 32nd inch ball, but I don't think that matters.
Shouldn't.
I wonder how many flutes that had. It was probably 2.
It should be 2, yeah.
No, the random tool that I used in my tool library.
Oh.
What?
I hate this pocket.
You hate this
shallow.
pocket?
It's too shallow.
It's for 2 millimeter cork with 1 millimeter sticking up. There you go. I wonder why that cut more on the corners. Oh, I turned on mist. Oh, I don't know what I did for this toolpath. This one might have nothing.
You had flood. I turned
For
it
the
on.
engraving, I had mist. That was not the most exciting toolpath we've done today.
Not so much.
I wonder if there's room for a product line that is wall control for machining products thanks to your guys' bins here. I don't know. How are these held on? Screws from the back? Oh, you have threaded inserts in the sheet metal?
Yep.
Or nuts in the back?
Threaded inserts, yep. Just like these.
You know I'm putting Gridfinity on this, right?
Using Gridfinity. Did you do 2 passes?
I think so. Oh, did I not?
Did you select it on the top, not the pocket?
I bet I know what I did. Oh no, I did a negative axial offset. Unless axial offsets are supposed to be positive. That's supposed to be cutting 2 thou deep right now.
It certainly is not.
Is the mist on?
It is.
It's really quiet.
It's turned down really low right now.
I always turn my mist up to a higher pressure than it was supposed to be at. Nope, doesn't like that. Now I have, on my Haas, I plumbed in just straight line pressure air blast. And I really like that for some places.
Yeah, makes sense. Swirly. I don't know if you want to get a shot of that engraving. Engraving looks good.
Are our mics still connected?
Hey.
Ooh, hose.
A little swirly from the contour, but
Probably just fed fast.
yeah. You want to get the trace ready for the third op? Run that real quick.
I suppose. Try to figure out what I did wrong.
And then we can tear the machine apart.
What do you think this was? Normally I see that from Backlash.
Did I not have any overlap on the finish?
I don't know.
Yeah, maybe not, because this is your account. I have it set at 200 thou by default. Something you should look at on your Haas. When it does, like if you wrap it in a 5-inch square or whatever, and then you tell it go across the square, when it's going across, check if it rapids at the same rate then as it does in like just X or just Y.
Okay. It's a diagonal.
Yeah. Because that's a discussion about like, are dogleg rapids actually faster? And I know it's a parameter, but by default on every Fanuc machine I've ever seen, an interpolated rapid move is the same speed as just a single axis rapid move. Which is, I just assumed that dogleg rapids were always faster. But for us, they're not actually, because we don't do that. Our XY rapids are 1200 meters a minute, but if you go in an XY move, it's 1600.
Okay.
Because it's just
Twice as many
Pythagorean
motors.
theorem. Yeah. Oh, this is interesting. Something I never thought about before a few months ago.
My problem is I had to tune down the max rapid on my Y motor because it was like the encoder I think is going bad, and if you rapid it too much, it airs out.
It just gives you a following error or whatever.
I don't remember the exact error. It's not just a following error, but it's the encoder being unhappy.
Oh, okay.
It might be a following error. I don't remember what it says.
This is actually fairly deep. You lowered it, and I had 3 thou of wear comp in here.
Oh.
So, oh well.
That's all right. It doesn't look like anything's getting eaten.
No, it's still cutting.
Did you put the side down that had the little bit of the mismatch? Or is that sticking up?
It's sticking up, I think.
Okay, well, that's fine.
Oh well. Sand it out.
What is that from? Is that backlash?
Did you check if there was any overlap on the finish?
But theoretically, on the theoretically perfect machine, that shouldn't matter, right?
I've never seen that. Granted, I've never looked at a kern. Wait, hold on.
There's a little bit of overlap. Not a ton.
That's
Those lead-ins are awfully sharp.
yeah.
I normally do a bigger radius and a 45 degree.
Yeah, I leave it at 0.2 normally.
That was fast. Oh, my simulation times are probably over projected because I have them tuned down a little bit for my Haas. It looks good though.
Yeah, not bad.
I think we've made a finished thing.
We have made a thing.
Piece of cake in this machine.
Deburring didn't do a whole lot. Should have gone deeper with that. But oh well.
I only gave it yeah, okay, it needs a little work. I only gave it 3 thou because I didn't want to go into the bottom of the part.
All right, let's start tearing the machine apart.
We made a mistake. Did you have a contour on this side?
Yes.
We contoured on the wrong side of the line.
Still counts as a thing.
It is still a thing. It's a fairly pretty thing. Machine leaves really good finishes. Well, shall we transition to the nerdy dig into the machine?
What's that?
Should we transition to the nerdy dig into the machine?
Yeah, once I
side?
get most of the chips out, I'm going to start tearing it apart.
Well, let's start by talking about that. All right, Norman, tell us about coolant and chip handling on this machine.
So, on the 1500, have a few coolant options. I'm going to stop that right there. So we've got our standard flood coolant system. We've got a ring of nozzles around the spindle, fairly similar to what we have on the 1100s and 770s.
And this is better than what you have on the 1100s.
Yeah, so this gives you more degrees of coverage. We currently have 4 nozzles on there. We'll revise the design a little bit and have 5 or 6 for even better coverage.
What power is the pump?
So it's a 1/4 horsepower pump. For
Really? It's only a quarter?
Yeah. 3/4 inch lines on the pump. Line restriction is actually the major reason for the increase in performance of the flood coolant system. But 1/4 horsepower pump for your standard washdown system, or standard flood coolant system. We also have a washdown system with 2 bars on each side.
So there's the washdown.
Yep, so 1 bar on each side of the machine. Those are powered by a separate 1/2 horsepower pump.
Oh, that's more power, huh?
Yeah, we just need more volume.
There's a lot more
washdown.
nozzles.
Yep. Yeah, a lot more nozzles. We're just trying to move more coolant. And those just flush all the coolant down to our troughs. And then out
Let's follow it.
Yep. out to the back of the machine, where as standard we've got 2 baskets for holding your chips, or later we'll have an option for a chip conveyor system that would go in the basket's place. On each pump we have a filter as well, just to make sure we don't get coolant clogging all of our nozzles. And then we have a mist coolant system here, made by a company called Unist. That's an oil-based system, but still blows air, similar to our fog buster that we had previously. And we don't have it on this machine, but we also have an option for a through-spindle coolant system, which, as the name implies, your coolant would come straight through your spindle. That would be a separate pump sitting to the side of the machine, and we have another filter and pickup for that going to the...
Can we go see a different machine that has the chip conveyor and everything in the TSC?
Yeah, can.
All right, I'm gonna stop.
So this is our through-spindle coolant system here, sits under the side of the machine. This is a prototype unit, so the production unit will be able to go a little bit more under the machine, so it's not taking up much more floor space. And then this is our prototype chip conveyor as well. You can see inside that we took our baskets out, and it's just picking up coolant and chips from our troughs. We'll have a barrel under here as well. For our flood coolant system, we could show the pump a little bit. Fairly dark in there, but this is a 400 psi system. We've got just our standard electric motor, and then it's a gear pump on there. A couple pressure sensors as well to make sure that we do have pressure when we command it on, but also that we're not spiking the pressure from deadheading the pump. But if we do deadhead the pump, we have a bypass line, this guy right here, where any excess pressure over whatever we have the set point at will just be dumped back to the tank, so it's not going to blow up the system.
400 psi.
400 psi.
Do you know what pressure the normal coolant system is?
35-ish. I'm not positive on that. But in a little bit, once Jakob's finishing, we can show the flood coolant, or the through-spindle coolant turning on.
Cool. We'll come back to that.
Yep.
All right, so we went through coolant. Now we're going to look at motion systems.
Yep, I'm going to take a couple of the covers off, and then we'll show the linear rails and ball screws and just the layout.
So to start with, real accordion cover or real way covers, not the little accordion things.
Yeah, so stainless steel way covers on every axis. The table is covering up the x-axis, but on the y-axis we have just a folding system on the front. On the back side, it's just one solid sheet that's bolted to the saddle, and that'll just travel through the column, just like any standard VMC, essentially. The Z-axis is an armored bellows system. You can see the fabric under here. So these are just all linked together, and then they'll just ride up and down with the Z-axis as we go up. And then on top, our headstock cover is just outside of the enclosure, so it'll protect the motor and spindle.
Do you ever need to clean those? Or does the washdown take care of it?
The washdown will take care of it, depending on how much material removal you're doing. We took off quite a bit of material earlier today. So there were some chips packed up right on the front here, but most of that's just getting washed down by the coolant. So just like at the end of the day, or every few hours or so, just spray it down with the washdown gun, and you'll be good to go.
And I don't think we said earlier, but there is a dedicated washdown for the y-axis.
Yep. Yeah, so...
Not bellows. I keep wanting to call them bellows in the back. The way covers in the back.
Little hard to see, but we've got a sprayer nozzle right here. Yeah. That anytime you have flood coolant on, that's just going to be washing down the backside of the y-axis bellows. Just make sure nothing
super nice
packs up
feature.
back. Yep. Yeah, that's just standard with the flood coolant system. So we'll take the covers off next then, unless there's anything else you wanted to get to first.
Nope.
Okay. I had a specific note in my list of feature requests of no Phillips.
It's a good call. So that's just like a kind of protective decorative skirt on the front?
Yep, so this is just to overlap the y-axis cover. Otherwise, we would have the joint where the cover actually bolts to the saddle, and coolant could get in there, coolant or chips. So
makes sense.
couple screws to take this guy off.
So you guys designed this machine, right?
Yep.
Like ground up?
Yep. Every single little screw. It's just, most of it took, well, the details are what took most of the time. For example, the sheet metal for the headstock, this is revision 9, I think.
Wow.
You might have seen on the first prototype that like this power drawbar button was on the left side. We moved that over here. There's a separate panel right behind this one that is bolting to the headstock casting. This angle was changed. We changed the dimensions on some of those, like how far forward that angle was. So yeah, just going through a lot of tiny little details to make sure that everything works as it should.
Which is good because you guys have PathPilot, which is, I think, the best controller. I've never used one of the Datron ones, and people like those, but PathPilot is good.
I mean, it's kind of in the same vein of Heidenhain. Like, you've got your guys that really, really love it, and then guys that just... There's a lot of extra stuff built in that a fair number of people don't feel they need. So it just depends.
Okay, so we can see trucks and lube lines.
Yep.
I want to look at lube too. So that was that little protective bonnet thing that went here, which protected all this stuff. And now we can get the Y-axis weight covers off.
Right. Maintenance was a thing that we kept fairly well in mind as well, especially for my suggestions for the machine. You notice the manifolds, they're all right here at the front versus buried inside the middle of the saddle where it'd just be a nightmare to get to. On the back side of the headstock sheet metal, there's an access panel to get to the Z-axis motor if you ever have to do anything with it or the ball screw. We'll be able to see in a little bit too, the ball screw nuts are actually facing towards the motors.
Okay.
Or sorry, away from the motors in case you ever have to replace a ball screw. We don't want the alignment of the motor to be changed. So we made that change to the ball screws so that you would be able to remove the entire ball screw without having to do anything with that motor mount.
Is this still belt driven?
The spindle?
Yeah.
Yes.
Okay.
Belt driven.
Is there a high and a low range?
No, single range on it. That button in PathPilot is completely gone. So
Okay.
You don't ever have to worry about that. Between the motor and the spindle cartridge is also a timing belt versus a V-style belt that we've had on our previous machine. Cool. So I got the front weight cover pulled back again. So now you can see our linear rails and our ball screw.
Do you know what size rails these are?
I am not 100% positive, but I believe they're 25 millimeter. The ball screws I know are 20 millimeter. For X and Y, they're 10 millimeter pitch. Z is 5 millimeter pitch. We just needed the additional torque for holding up against gravity. That's why on X and Y our rapids are 1,200 inches a minute versus on Z they're 600. It's just the difference in the pitch of the ball screw. So we'll move this back a little bit more.
How about homing?
So on the 1500, if I e-stop our machine, right here where we've got our green LEDs, this is where normally we'd be seeing reference X, Y, Z, just like we would for A. But on the 1500, we have absolute encoders installed on the motor, so we don't ever have to reference the machine. That battery will just...
The mic will still hear you.
Okay. The battery will just keep position even if you e-stop or power off the machine. That battery will last for approximately 5 years. It is a little bit variable depending on how long you leave the machine off, where it would be consuming battery power.
So it's better to leave the machine on?
Generally, yes. But the major thing is actually if you move the machine while it's powered off, that will rapidly deplete the battery. So avoid doing that. But you could just leave the machine off, for a couple months. It won't be an issue at all. But we have a battery on the A-axis as well. In this case, We've never referenced it, so once we do that, as long as you leave the A-axis plugged in, you wouldn't have to reference it again. But if you ever do pull it off, then you do have to re-reference the A-axis. And we can see on here, we have a 0 mark on the faceplate that rotates, and then just a engraved line in the housing of the A-axis. So all you have to do to re-reference your A-axis is hit reference. Oh, and I have my door open right now. I was not able to reference. You'll get a pop-up saying align those 2 marks. You press OK. And then we're going to rotate and find the nearest index pulse of the encoder and back it up. So you only need to be within about 5 degrees by manually aligning it. Everything else is just handled by the homing routine. And then that'll hold it until we re-reference them, pull off the A-axis. Otherwise, it'll still be referenced. So
It's going to be a pain to see inside the head, isn't it? That's probably not worth it.
yeah, because
That's not worth it.
There. All right, I'm going to drop the the Z-axis cover still though. Before we do that though,
What are you most excited for this machine as a tech? Like what feature does nobody else care about, but like you get excited about?
it's fairly hard to pick one actually. If I had to say one, I'd probably say EtherCAT.
Okay. Which we'll get to.
Yeah, we'll get there. But outside of that, my experience has primarily been on robo-drills and Nakamura's. So robo-drills especially, other than size, it's the exact same components. We don't have a fully supported table, so there's one less iron casting for the saddle. But other than that, linear rails, ball screw, field bus servo motor on there, standard weight covers. So we're not missing anything, is how I feel. This, to me, is a huge step up. But to me, the 1500 is step one. Everything we do after this is going to build on it. But this is just such a huge step for us. The one thing I would say I wish we did more on the 1500 is I always want more spindle power.
Yeah.
Spindle power is an evolution rather than a revolution, like everything else on the machine is. But yeah, like the next 4 or 5 years, once we start getting everybody in the main swing of using these machines, will just be really exciting. So there's a lot of little features that we put in the machine as well that I feel like being able to have the input in those just made the machine better overall. We don't have them installed on this machine because it's one of our prototypes, but on every machine we have 2 airlines run to the table. We have those airlines running through the cable chains all the way up there, and they're just plugged so you can use them for whatever. If you have some automation system or something you want to plug in. But otherwise you'd have your lines dangling through the machine, and they can just get in the way of everything. So just having those available is great. On the homing side, I didn't mention it earlier, but if your batteries ever do die on your machine, you don't have to worry about running out and getting a set of D batteries or whatever to replace them, or having an alarm that means your machine is down, over the weekend. I can just hit our LED, and it's telling me it's already referenced, but if I want to, I can just re-reference the machine. And if I do that, after I shut the door...
Does it work with the way covers all?
It'll still work.
Okay.
But I'm going to do X instead of Y anyway. Re-reference.
Same thing as an 1100 where it finds the end of travel and then looks for an index pulse? Okay.
Yep. Yeah, so we're running into the bumper end of the end of the travel. We notice that torque spike from the load on the motor, and then we'll back up to the index pulse of the encoder. So you can remove the batteries off of every single drive and still do hard stop homing. And until you power off the machine, not even e-stop, it's going to retain the reference. So you can just run that. And that was a feature that actually came later in the development. So our prototypes ran that way for 6 months, and it works perfectly fine. So.
I'm going to take our Z6 cover off as well.
So we're opening the Z-axis way cover now.
Yep.
Now we just need a air knife or something so we can film easier inside the machine.
You could add one.
That's true. I could put one on the table with the camera, with one of your Hey, look at that.
You could. Of course.
I thought you were missing fasteners here because it was a prototype machine or a showroom machine or something. No, these are pinholes.
Yep.
That makes sense. So that way, if you have an 8-foot bar of material sticking out the side, you can just put it up a couple levels.
Yeah. So this level.
That's
if you
for
get
whoever.
down, you've got about an inch to the top of the table for this one, and then you gain a foot for each additional step.
That's for whoever makes it into a, who adds a bar feeder to the six axis, the micro arc.
Yeah. You could try doing that.
He said it had like a 30 millimeter through hole on that micro arc, which means you can now load 1 inch round, which is good because 1 inch round is, you can get a lot out of it and it's cheap and easy to find in a lot of materials. And there goes the screws.
Yep. Lost the screw.
Is the spacing between the rails the same on all the axes?
That I am actually not sure of. I'd have to ask engineering on that. I'm not sure where my screw went. So, exact same setup here, just our ball screw and then our linear rails. They are all the same size linear rails for each of our axes. One thing that is different about the ball screw configuration that I didn't mention is that on all of our previous machines, they had a fixed free configuration. So we had our 2 angular contact bearings on one side, and then the other side of the ball screw was just hanging.
Floating,
yeah. So that doesn't affect performance, but that does limit the maximum speed that you can run that ball screw at because the end of it will start whipping. That does depend on how much length is actually free. The closer you get to the end of that, theoretically you could move faster, but practically speaking, your limit is the farthest unsupported length. So on 1500, we changed that to a fixed simple configuration, where on the far end of the ball screw, you can see for the y-axis here, and the same for the z-axis, and it's also the same for the x-axis under the table. This is just a regular rolling bearing, so you don't have axial support for length, but you are controlling to make sure that that ball screw doesn't whip. So you can run it faster. That's part of the reason we're able to go up to 1200 inches a minute. That's fun. I mentioned earlier the ball nut. So if you look up on the bottom there, you can see the flange.
And I see a lube line going to it.
Yep, we have lubrication lines going to all of our ball nuts, as well as to all of our linear bearing blocks. So in this case, this is the flange for the Z-axis ball screw. So this ball screw has to come out down rather than going up the top, like I mentioned earlier. So we don't have to do anything with the motor mount and change the alignment of the ball screw after we replace it. So you can just drop this ball screw, loosen the coupling on the motor, and then take the entire ball screw out to the bottom. That's cool. For the Z-axis specifically, there's a channel in the epoxy granite frame that gives you enough length, once you also take off the Y-axis cover, to just take the ball screw out, throw a new one in, and then you're up and running again.
What's that? Oh, sorry. I'm distracted. What's that hole? What does that go to?
This hole?
Yeah.
This is just for cable passage. Currently not being used for anything, but there are some plans.
Future expansion.
Yeah. Yep. So you can see for our linear rails, right behind it, we've got our pusher screws, pushing each of them up against a reference edge. And then they're bolted onto a replicated surface on the casting. So those are our precision surfaces that we use for mating everything and ensuring that we're straight and square. And then we have the
rest of the casting. Outside of where the rails and bolt and ball screws bolt is honestly just support material, but it does a great job of dampening vibration, which helps on your surface finish.
Is there still a machine that doesn't have an enclosure on it where we can look more at the casting?
We don't have any without an enclosure here.
There wasn't one in the other room?
Oh, never mind. I forgot about that one.
Let's go look it out.
Yeah.
This is an 1100 with an auto
Being
door.
decided this week mostly.
What happens if you turn on through spindle coolant on a tool that doesn't do it?
There's already a video on YouTube of that. So that bypass that I mentioned,
Okay.
you're going to deadhead the entire coolant flow through the spindle. So that's going to build pressure in the line, but that's going to come back to the bypass.
Okay.
And that's just going to dump back to the tank. So the system will maintain 400 PSI even though it doesn't have anywhere to go.
You're just wasting energy at that point and stirring coolant.
Yep. So I'm just going to show it first with no tool in there. So we've got a button on the UI that I can use. And
that makes for great video. I'm glad you closed the door though.
I have seen it without the door closed. Not quite as fun as you would think.
We've all done that.
Yeah. But if you're ready, I'll do it again.
Okay.
Yeah. It is effectively instant for it to come on. So I think, which tool is that? Tool 9, I believe.
This is slightly terrifying.
A little wobbly, yeah. The Centro is worse and heavier.
You need like a 3D printed cone to go down in there.
Yeah, you could.
What is this?
That is a ring gauge. That's used for calibration of the spindle probe.
That makes sense. Does it have a size on it?
Yes, they'll have a size
and
on it.
Down to the, is that a millionth?
Nope, tenth.
Oh, it goes past tenths. It goes down to the tens of millions.
Okay. So we do have our button in the UI for through spindle coolant, but it is also M code activated. Yes, I forget what our M code is for through spindle.
There we go.
There we go. Yeah, M207 for through spindle coolant. If you just have it in a program or built into your post.
Man, end mills are going to be so much more expensive on this.
If you get through spindle coolant end mills, this one's from Helical, I believe. But you don't have to have a through spindle coolant end mill. You could just run it through a standard call it. Yep. So the downside of through spindle coolant is you always get some dripping too. So it'll just keep running for a few seconds as it drains the lines.
That's fine.
And as a demonstration, I should just put that back in the ATC. Store that tool. So this is just our master tool.
Calibration tool?
Yep, for calibrating our ETS. Obviously it's just blind on the end, so no hole through it.
So you're about to try to run coolant through the calibration tool?
Yep. Don't tell my boss.
Or the metrology nerds.
Yeah. Well, that's running right now.
Nothing exploded.
Yep. And you can't even see it, but our pump's running, and we're going back through that bypass valve back there.
Can we run the chip conveyor?
Yes.
Turn this
I'm going
off
to take
first.
this out first. So turn that off.
Oh, in the washdown.
Yep. So you get a little spurt of coolant.
Because you just pressurize that to 400?
Yes. But it's not going to hurt the machine or you. Just get you a little bit wet. And then wash down. We've got our 2 bars on the side. Another button on the UI here. That'll turn it on or off manually. And in a program, that'll just turn on with M208 or turn off with M9 and 209.
So how would you normally have this in a program? Would you just turn it on and off once every couple minutes, or would you leave it on all the time?
So you generally would probably just leave this on all the time. You can run it intermittently if you want, but there's no downside to having more coolant washing down in the chips. You can let it build up a little bit and then try to wash down the chips if they're really light or really heavy. That might help it wash down, but just depends on the situation. So, for our chip conveyor, we've got manual controls here. Oh, cool. We're going forwards. Or if you have a jam for whatever reason, you have a secondary button for reverse. And then small potentiometer for speed control.
Cool.
Yep. So the speed control is only set on the control box here. And then you do have your manual buttons, but we also have an on-off command that can come from the machine. We do have another UI button that's currently not implemented, but I can remember our M code, which I believe with M232, 31, did our conveyor turn on?
I hear sounds. Yep, it's going forwards.
Yep. So if we use M231, that'll just continuously turn the conveyor on. You can add P and Q arguments to the M code. That'll set time on and time off if you want to run the conveyor intermittently. That way you can let coolant drain from the chips that are built up on the incline, run it for a little while, refill the incline with chips, let those drain, and so on and so on.
Is any of that set up in the post, or do you have to use like a pass-through NC?
So that will be built into the post. The problem is being able to select the different timers if you want. So that'll probably just be manual added if you want, or running the M code. That'll be built into the post as an optional selection.
And this thing, is this available yet?
No, the chip conveyor and through spindle coolant aren't currently available as of summer of 2024. Those will be available fall of 2024, but we don't have a specific date for release yet.
Is there any installation process?
Yep, so these are add-ons to the machine. Even if you get a factory assembled machine, these will still have to be installed as well. But for through spindle coolant, you obviously have the main unit here that sits next to the machine. You do have to run the coolant line up through the cable chain to the spindle. So that'll just be running the hose essentially. And then you're installing the rotary union onto the spindle. That's it for installation of the TSC essentially. There's no electronics you have to wire or anything, just hook up power to the TSC unit, connect your control cables, install the rotary union and the hose. For the chip conveyor, it's essentially the same story. You do have to remove the baskets from the coolant tank. In that process, you might want to drain the tank, but it's not absolutely required. But then you're going to have to put the chip conveyor into the tank, which will require a forklift to do. You don't want to do it by hand, that can be fairly dangerous. But then your control cable to the machine, that'll just plug into a port on it, and then you're able to run. Just supply power to it.
Could you do that with like an engine hoist, or do you actually need a forklift?
Never been tested.
Okay. Don't try this at home, kids.
I have doubts of being able to do it easily because of the feet sticking forward. Those are probably going to run into the coolant tank. So this is our unit system. So this is for mist coolant. We have our air supply running through it. This is unlubricated air, so we have it before our FRL. And then this is our container of actual oil. So we'll mix the air, the oil into the air, and then this goes out to our nozzle. With the unit system, you have a pneumatic flow control built into the unit, so you can precisely control not only how much air you're sending through the system, but also how much oil. So you can control that ratio very, very well. You have a control knob on the side here, and two more additional knobs here. So you can control not only how much oil is being sent with each pulse of air, but how frequently those pulses are.
Oh, so it's a pulse kind of?
Yes.
Oh,
yeah,
cool.
It's a pneumatic pulse generator, essentially. So you can set it, if you want to, that you have a lot of oil going in very few pulses, or a little bit of oil going in a lot of pulses.
Is the oil pulsed or is the air pulsed coming out of the nozzle?
Both.
Okay.
Yep.
And how high of a pressure can you set it to?
Unist recommends around 40 or 50 psi.
Okay.
But if you go above that, it's not going to hurt the system. You are going to consume a significant amount of air if you go above that, though. Yeah.
But the old, what was the Mistbuster? Those maxed out at like 30.
Yeah, those had a limit of 30 psi. And you weren't able to really control how much fluid you're sending in.
No.
You just pressurized the container and you got what you got based on the knob.
All right, so now let's look at the casting.
Do you want to go to the other machine?
So we should have a naked one we can look at, yeah.
Yep.
This is a giant cube of robots. Robots, robots, robots.
So this is the main casting for the machine. So it's a one-piece design. Once it's completely assembled, we have two separate castings. We have our base here and then our column. And we cover up the seam fairly well, but right about here is where the actual split is. We epoxy those two castings together to make them a single unit. But you can see that this is just a solid block of epoxy granite. So it does an extremely good job of dampening vibrations. And then we have a 3-point leveling system on the machine. So it's not even required that you level the machine, you can just drop it on the floor. That goes all the way down to the base. You can see that we've got steel plates that are epoxied into the casting as well, that we have our feet bolted into. But very simple design. We have threaded inserts for various panels, our tool changer, the enclosure to mount to, our electrical cabinet as well, and then all of our hoses and cables. Y-axis cover goes underneath the column right there.
Are these threaded inserts, do they cast those in place or do they cast it, drill them out, and then like epoxy them in?
They're cast in place. So we have a steel mold that's just a negative image, and the mold will have a through hole that they're just able to pass a bolt through. So they'll thread the insert on inside the casting, just hold it in place with the bolt, pour all the epoxy granite in, then they'll remove the bolt and then disassemble the mold to bring the machine out. And then after that, we'll do all the finishing and painting.
Do they like put it in a giant vacuum chamber to get out bubbles or shake it or anything?
That I'm not sure of. I know that the top surface that you get that's not covered up by the mold, that will have a rougher finish, which in this case is the backside here and the bottom of the casting. Those I believe that they do like with a blowtorch over to pop some of the air bubbles that come up. But I don't know if they do any specific vibration or anything. I would imagine so, because compaction is one of the major issues with the casting. You want to make sure that you have a very evenly distributed mix of epoxy in your aggregate.
And look how thick that is. That's what, 6 inches, 8 inches thick there?
Between these two holes, this is 14 inches-ish.
Oh, it looks like it stops, but it's drafted in both directions.
Yes.
Okay, so that's all solid. There's no hollow in there, except for a couple electrical passages and
we
stuff.
actually were considering whether we wanted to put a cavity in here. That idea was very quickly squashed by customs, because they would destroy the machine to make sure that there was nothing inside of it. Yep.
So you're not shipping drugs in your 1500?
It's been done in machines before. But yeah, this casting, a lot of the design considerations were put in place as far as weight and height specifically. The base machine without the enclosure or any add-ons is 2,800 pounds. That's because the limit for liftgate delivery is 3,000 pounds. So we needed to make sure we were right under there to make sure guys can get machines in the garage. The entire machine is underneath an 8-foot ceiling without the mist collector on it, to make sure it can fit in most garages. So those were definitely in mind as we were designing the machine.
Do you have a pallet jack? Can we see how a pallet jack fits under it? I don't want to lift it. Let's not lift it, but... All right, we're recording again.
All right.
All right, we're not actually going to lift it, but I just wanted to see how the pallet jack fit.
Yep. So
Wow, right from behind.
with a standard width pallet jack, it can fit. It is very, very close though. On these spacers, it's basically a horseshoe shape. So there's a cutout on the side of them in order to get them around
Really?
our rod. You have to have that flat of the cutout oriented in on both sides. And I don't believe that was done on one of these sides. This one it is. Yeah, that one's off a little bit. So very, very close, but as long as you orient those properly, you can get a standard size pallet jack in there. Alternatively, use a
narrow pallet jack.
Yep. This will fit without a problem.
I like how it's designed so that the heavy column of the machine is right at the back of the pallet jack.
Yep.
That is nice.
You can lift with the pallet jack at the front of the machine as well. You do need to make sure that you are fully inserted with the pallet jack, and also you want to take off this kick plate for your regulator in order to let you get a little bit deeper. The jack of the pallet jack will hit right on there. But yeah, you can move the machine from the front side as well if you want to put it up against a wall and then lift away. So these plates that our feet are bolted into, they extend about 5 inches into the casting. So both in front and back, that's actually what we're lifting on the pallet jack.
Can you pallet jack it from the side at all, or only front and back?
You really don't want to try moving it from the side. If you have a forklift, you could set your forks facing so that you're still on those steel plates.
Okay.
But you do not want to be lifting on the actual epoxy granite itself.
Do you need fork extenders?
You'll probably need fork extenders as well. If you have six foot forks, you shouldn't need them. But if you have 4 foot forks, then you'll need extenders, yes.
Does this one have the in-table air?
Yes, every single machine has 2 air lanes.
Okay.
Or to the end of the table.
And those are normally open, right? Or well, they're not even normally open. They're just always open because there's no switch.
Yeah, there's no solenoid. They're just plumbed straight into the manifold. So as long as the machine is pressurized, those are pressurized.
But you could theoretically put a solenoid on the back, or if you had like a valve, you could put it on the table.
Yeah.
For like a Chuck Puck or a Pearson system.
So those 2 lines run to this splitter right here. So if you wanted to, you can just take this off, cap this port, and then run these lines to whatever you want. A solenoid, some kind of manual valve, have it robot controlled, whatever you want.
Is there any other air system things we should talk about?
Nope, that's it for pneumatics.
Well, there's the air gun in the front, which has its own regulator, which is nice.
Yes.
So I'm not sure if this one has one, but air gun hose with air gun there, and it has its own regulator.
Mm-hmm.
And it looks like you can go lefty if you want to.
Yes. Very, very important. Most important feature on the machine.
Is it hard pipe to that, or?
Yep. So that manifold we were just looking at, one of those lines comes right up here underneath the enclosure. So that's just always running. We didn't look earlier. Scratch that. It's not on this machine. But for the flood coolant system, if you have it installed, your washdown gun is mounted right up here. Additionally, if you have a probe installed, the receiver is sitting right behind your controller here. So we have our cable running up above and then back to the controller.
Ooh, it's an Allen key to open, not a coin.
Yes. So we have our main electrical cabinet here. We have a secondary electrical cabinet for the ATC if you have that installed. That just contains a breakout board and the ATC servo drive. Otherwise, fairly simple layout. On top, we have all of our servo drives, spindle, X, Y, Z, and A, if installed. Underneath, we have EMI filter, 24-volt power supply, and then an I/O breakout board. A couple circuit breakers, terminal strips, and contactor for our spindle drive. But compared to our previous machines, fairly simple layout. Everything in here is either 220-volt AC or 24-volt DC, so standard industrial voltages. Each of these drives is connected to our EtherCAT chain. So we have just regular Ethernet cables, daisy chain from each drive, as well as a bulkhead connector right here that'll go out to our ATC electrical cabinet. So each drive also has I/O built into it, has several digital inputs and outputs. Those we run to our I/O breakout board, and those control any of our sensors, our switches, our door lock, coolant pumps, any device we need to turn on or off. We have that I/O built into the drives, so we make use of it for everything we need to control versus having separate I/O modules that just add cost and space to the cabinet.
So there's no Mesa board or anything to
Nope.
the interfaces between the computer and the control.
Yep. This Ethernet cable runs straight to our control. No control board whatsoever. It's just all on the EtherCAT bus.
That's really cool.
Yep.
So from factory, without any add-ons, what unused I/O does it have that you could use for automation or whatever?
So everything is already pre-assigned. We do have one input and one output assigned to be accessory input and accessory output. So those can be used for whatever you want. We also still have our USB I/O module that can be used for general purpose with M64, M65.
What are these? So these are, okay, accessory 1 and 2.
Yep, so these are the accessory inputs that I mentioned. One of those is actually used for the through spindle coolant system for our pressure sensor.
It's not this one?
You're correct, actually. So these are our
I read
accessory inputs. Yeah, and then we have TSC that connects here as well. So these two are our inputs. We have additional connectors a little bit hidden on the bottom of the machine. Those are our TSC and accessory outputs, as well as our probe connector. This cable is from our probe receiver, so just one cable runs straight to the machine. We have a couple connectors inside the machine as well. This one is for the solenoid for our UNIST, and then you can see drawbar output, our door inputs, spindle fan. So everything's easily connectorized. If you have to replace a component, if it fails after a number of years, you just unbolt it, run a new wire for it, and you'll be up and running again. We have our layout sticker here as well. Just trying to keep maintenance as easy as possible, so you don't have to go digging, into page
Googling
47 of the manual. Yeah, if you need a part number for a drive, if you run it as hard as you can and you light your drive on fire, here's your part number. You can just call us up and order a new one. So, and of course, we still have our parts lists and layouts and electrical schematics in the manual as well if you need them.
This is one of those stupid small things that is so helpful and more companies need to do.
Yeah.
That is, this is why I like Tormach. One of the reasons.
Yep.
And look at our nameplate here. So it says single phase 20 amps at 230.
So 20 amps was on our prototype machines.
Okay.
Every machine does require a 30 amp circuit. If you get the TSC unit or conveyor, those also require a separate outlet and separate circuit.
Of 220?
Yes, 220.
Okay. Sorry, I'm just thinking about my plug situation. Oh, and here's the hose.
Yes.
Here's the hose and
That is
receiver.
our coolant washdown hose, and you can also see the probe receiver there.
Oh yeah, let's talk about the probe.
So on the machine, have it torn apart still right now, but you can see on the backside we have a probe in our tool changer. So that is a standard wireless probe and ETS as well. Those run off an optical system.
Like a Renishaw.
Yep, very similar. So yeah, you can use those with our standard built-in probing routines in PathPilot. Or we are also developing a suite of CAM macros that can, probing macros that can be used with CAM.
Did you say the brand? Okay.
Yeah, the probing system is from Pioneer.
So still BT30.
Yes.
Same pull studs as everything else?
Yep, still 45-degree pull stud.
Which, those are the same as the Haas pull studs, right?
I am not sure what pull studs Haas uses for BT30 actually.
Are they the same as like Robo or Speedio or anything?
They're the same as Robo drills. They also use 45-degree pull studs. Speedios use 60-degree pull studs.
So 10K RPM, 4 horse?
10,000 RPM, yep. 4 horsepower continuous, 6 horsepower intermittent if you're going over 100% through the cycle.
And we saw in the other video that there's the, what do you call it? The gauge on the path pilot controller.
Yeah, you have your spindle load meter for your spindle built in, as well as for all your axes.
Load meter. Yeah, that's the term I'm looking for. How does the drawbar force compare to this one, on this one to like the MX, or excuse me, the 1100 MX?
Drawbar force is actually the same. We have a spec of 1,000 pounds of drawbar force.
Okay, on both machines?
Yes.
Okay. What about bearings? Are they different on this machine?
Yep. I don't know the exact size of the bearings, but still a 4 bearing configuration, just a larger size. So on the 1100 MX, that was an 80 millimeter diameter cartridge, and on a 70 millimeter cartridge on the 770 MX, and on the 1500 MX, it is a 100 millimeter cartridge. So much more room for bearings.
ABEX 7?
Yes. Okay. They are ABEX 7 rated. Like, as far as the spindle, like that's made by Microlab. The linear rails are made by Highwind. Ball screws, not Highwind, but I don't remember who they are. I don't have a problem like naming companies, like Pioneer for the probe. I'm a bit hesitant to do so just because people tend to attach onto that, and we don't want to remain beholden to every 1500 MX will have a Microlab spindle. No, we might, if the quality goes down, we might kick them to the curb and get a different supplier, or if their costs go up or whatever. Yeah, people just get possessive about component brands. It's weird. Well, I mean, it's machinists. They do the same thing for controls, so I guess it makes sense. Okay. Having back together.
So our goal in doing this was to start playing with the ATC. Can you run the ATC with the door open?
Very limited functions with the door open. So we're on the ATC screen right now. You can see that most of these buttons are actually yellow. If I close the door,
oh, that's smart.
Those go to white. So you do still need some functions open for alignment and setup. So you can see here, set TC M19, TC position, or aligning the tool tray to rotate the carousel. So yes, we do have some functionality with the door open. In setup mode specifically, if you change to run mode, this is a beta version, so these will change yellow if you're in run mode versus setup mode. But for a full tool change, you do have to have the door closed.
Does that key do anything on the 1100s?
Not in the US. That is
okay.
CE
I've always wondered
specific.
about that.
Yeah, for 1100s and 770s, that is CE specific for allowing various functionality with the door open, being able to jog at 200 inches a minute versus limited to 78, turning coolant on, turning the spindle on. But on every 1500 MX, we do have certain restrictions in place, both for just our safety standards that we want to apply, but also CE conformity.
Okay. So can we time some tool changes?
Sure. I can set up a quick demo program of just running tool changes.
Okay.
What tool numbers do we have in the ATC?
Can you change from like 800 to 102 to 86, back to 800, then 102, then 86? That way we're doing one tool change that's right next to the other pocket, and then one tool change that's on the exact opposite. Can you still manually change out tools? Like if you just called up a tool wasn't in the ATC, it would stop and ask you to manually change it?
Yep. And it was doing that earlier when we were running the part. I initially didn't have the engraving tool loaded in the ATC, so it told me take it out before I go to a tool in the ATC. None of that has changed from what we've had in Path Pilot previously.
Oh, and how many tool pockets?
16.
And 12 on the 1100?
Yes, 12 on the 1100 MX, 10 on the 770 MX.
Okay. So more than a mini mill.
So we'll change from tool 102 to tool 800 to tool 86, and then do that again, a third time, fourth,
okay,
5 times.
I wonder if I can do an on-screen timer in editing. I'm going to do that.
We also have our cycle time counter.
Okay.
So if I'm going to start this first, I should manually change to tool 102 to begin with, though.
It's not the fastest tool changes I've ever seen. It's faster than the 1100. That's definitely faster than the 1100.
Yes.
That's a lot faster, turning the carousel.
Yeah, one thing to keep in mind too is that with 16 tools, we have a much larger diameter platter. So the inertia of the entire carousel is much
that's
greater.
real, yeah.
Yeah. So for our testing, we loaded up 16 half-inch drill chucks that had 6-inch projection. So if you have a fairly lightly loaded tool tray, we could go faster, but we have to keep in mind we have to set the speed for the worst case scenario.
Yeah. And I don't think that's, like, in terms of quote unquote wasted time, there seems to be a pause. Is that just waiting for the drawbar and everything to settle into place?
Yep. Yeah, so we do have a couple dwells in the cycle. Compared to what we had on the 1100 MXs, those are reduced quite a bit. But we want to make sure we leave enough time for the drawbar to open and that we're clearing off any chips with the air blast nozzles as well.
It's not a speedio, but it's totally reasonable.
Yep.
That's probably good.
I'll let it run through the whole cycle.
Okay, then we can, how many tool changes are in that?
So we started at 102.
15.
14.
Because the first one's not a tool change.
Yep, so 14 tools.
14 tools, where's the, and we're coming up on 2 minutes?
A little over.
I'll get my calculator ready. Where's my calculator? Time, 2:33 and 14 tool changes. So we are at 10.92 seconds of tool change.
Yep.
And half of those were worst case scenario.
Right.
I guess half of them were best case scenario too.
Yeah, so that's fairly average.
Yeah, that's not bad. That's pretty good. All right, so rough operating with, give it a little bit of margin, like actually real what you would want.
I'd say at least 18 inches for me to get
This
to the
is
side
slightly
of the
larger
machine.
than 18 inches.
Are you at the side of the enclosure or no?
No, I'm a couple.
Well, you go 18 inches and I'll measure to the side.
So 18 inches.
Okay. So we're at 7.5 feet to the side of the mouse pad here.
Okay. What about depth?
So.
All right, I'm not going to give the operator any room. No room for the operator, about there.
So this is to the back of the unist, which
so if you don't have a coolant system.
Right, if you don't, it's just under 6 feet. You add in the coolant tank, you're at about 7.5 feet.
Okay. How much room do you need back there to maintenance and stuff?
So you really only need the width of the coolant tank. The door of the electrical cabinet, when it swings open, it's within the footprint of the coolant tank. So as long as you're able to stand comfortably, if you're having to do any electrical maintenance, and you're fine there, the coolant tank itself can roll out straight to the side, so you don't need any additional room behind it.
Yeah, and to be fair, you have it pushed up right against another machine.
Yes.
So
yeah, and we have had it pushed up right against the wall with 3 inches of room-ish. So just depends on your exact machine placement, really.
Cool.
Yep.
Well, do you have anything else cool to show us?
Nothing comes to mind.
All right. Well, thank you for the deep dive tour. I appreciate it. It's been a fun couple days.
Yeah.
All done. Finn.